Do I have volume? Yeah, I have volume. Okay. All right, all right. Yes, sure. Here I am. I don't get why the Focusrite gets top spot on my audio sources. It's kind of odd. I guess the mixer did come in afterwards. I wonder if it does it by some kind of like USB ID. All right, let's get the YouTube chat popped out. There it is. And you get the side of my face as I look at the monitor that's all the way over there. Pop out chat, close that. There we go. Now we got everybody. How's everybody doing today? It's Friday, so I don't feel like thinking. So we're gonna work on this thing. Donk. This cool Nixie tube digital readout. I'm afraid to hit this button. What's up, 3D lasers? If I hit this button, it'll zero this, and then I can't alter it anymore. I think I can tap some of these pins together from the last time we looked at this thing. We took it apart. We're gonna take it apart again. I wanna take another look at it. And I think the end result might be that I spin off a ESP that will allow us to control it. So if you guys enter numbers into the chat, I'll have it tick up that amount. So it'd be like between 1 and 100, and then we throw it onto a packet. The packet reaches this guy, and then the ESP will tap the wires together, essentially, a certain number of times. This is a DRO without the actual reading device. It doesn't have the measuring thing, but it would be done in a series of pulses, I guess. Oh, that's right. I got to switch to Firefox in order to run these playlists. YouTube playlists are cursed now because uBlock Origin is dead. I still like this song. I love this song, actually. Okay, it's not auto-focusing, it's just auto-brightnessing. And since it sees this void sitting in front of it, this whole black screen, it flips out a little bit and overcompensates. This thing's cool. My brother sent me this. I guess he must have gotten it off of eBay or Craigslist or something, but it's a cool Nixie tube digital readout. It's not the featureful one. This one only has one readout. There's two on the featureful one. It's just not working on Chrome. They stopped. They don't allow you to run it on Chrome, and I think what it does is it keeps. Hold on, let me see if I can do. Let me see if I can re-enable the extension. Because I know a lot of people just told it to keep working, but Chrome stopped it. What do we got down here? Oh, did it remove itself? It did. What the hell? Wow, they really hated uBlock, didn't they? They removed it on this computer. It was on here. What the F? Huh. I don't know how I can get it back onto this computer. Yeah, it works on Firefox. I've been using Chrome. I just never switched from... I originally used... Well, I originally used, you know... What was it called? Why did the name just suddenly leave my brain? My old brain... Netscape. I used to use Netscape, let's be honest. You know, but no, like when all the browser-y Chrome stuff started happening, I was using Firefox, and then I switched over to Chrome, became reliant on some of the Chrome stuff that was going on and how fast it was and, you know, throwing tabs everywhere. But now that privacy is dead, I guess I'm going to move over to Firefox eventually. The stream computer just didn't use it for the longest time because I made the switch on my main computer, so I'm still using Chrome on this machine, which means no uBlock Origin because they killed it essentially. And it looks like, by the looks of it, it uninstalled itself during a Chrome update, which is even slimier of Chrome to do. They're not getting a lot of points in my book anymore, and I'm probably going to be switching over soon to Firefox on this machine. It shouldn't be too painful. Firefox is just a little bit slower, or it's a little bit jankier in some places, but it's not that bad. And having that invasive ad block is somewhat necessary if you are a purveyor of the useful side of the internet. So it just sucks. I just don't want to change. Straight up and down, don't even bother. I am practically going to be sitting on the fan today. Hopefully you guys don't hear it. Is Brave Chromium based? I've heard of, but I've not used. What's the heat look like on this thing? We gotta see what the steady state heat of this device is too, if I'm gonna be running it alongside stream. No, I haven't really tried many browsers. I just found something that works and rolled with it. Oh my god. Okay, I gotta, this is, between each 3-minute song there's an ad, you gotta be kidding me. It's like, what is this an ad for? Is it Mauser? I think it is. No, you are not what we're gonna listen to. Where is my, no. None of this. My, oh, what's that doing over there? Oh my god, we're pulling tabs out of nowhere. DJ every day. We'll go back to DJ every day. Oh, I guess we're picking up where we left off. That'll do. That'll do. Never changed from Firefox. Must be nice. Yeah, I became a little bit too reliant on Chrome. It's nice to not have to install Microsoft Word on a machine and just be able to like type documents and do stuff like that in you know, all the different Google apps that exist. But the rug pull from that is probably going to happen too eventually. Although, you know, I can still use that Google stuff on Firefox and then I still get ad blocker. So what is that? Are you talking about this thing down here? That's a digital readout. How else are you going to know where your machine is if you don't have a digital readout on it? You got to know where your machine is. How many numbers are you from your other numbers? What are the numbers? Where are the numbers? Who are the numbers? And on the back, we've got all the inputs. It's a little dusty. And you can see that there's a whole thing that was never installed. There's a whole piece of functionality that was never installed. I don't know what this one is. Long axis? Huh. I don't know. I guess that reverses it. The weirdest DRO I've ever seen? Yeah, I've never seen anything like it. I told my brother, I said, get me weird tech stuff. And he outdid himself with this thing. In my mind. It is a lot of hullabaloo for what it is, but seeing these numbers count is, oh no, I zeroed it. Shit. Seeing the numbers count is really cool. I didn't mean to accidentally hit 0 when I tapped it, and this is a really sensitive button. There is a way I can tap these together, but I don't remember what the sequence was to tap them together to get the numbers to move around. We're gonna probably send it pulses with a microcontroller. But it's pretty neato gazebo. It's been, I think it's been sitting on the shelf for like a year. So it's high time we get back to it and do something cool. So, and that cool thing is just gonna be straight up letting you guys inject numbers into it. I don't know what else I would display on this thing. I don't know what else I could possibly put on here. It's like sub counts are not gonna get this high. Although there's a decimal place being put right there. But I can just count up numbers with it. I don't know if we can get to any of the alternative displays over here, because this one has more than just a minus sign on it. How the keyboard and the really narrow modular amp projects go, they're still ongoing. I need to build, I'm in the process of building the mixer again. I thought I was done. I built the thing for Julian, I got it to him, he tested it out, he said there's a little bit of noise at low volume. That's something that I don't know what I'm gonna be able to do about. Maybe add capacitors or something, but I'm in the process of breadboarding the circuit again. It's annoying. We got almost nothing done last stream where I was supposed to be breadboarding it. I need a working model of the circuit so that I can verify that it functions the way that I want it to. Because Julian changed things up a little bit. He said, well, why not, let's do one left and right unity gain input and then a faded input, and then you can change the volume on the output. And what that means is that one of those V2164s, those current controlled, voltage controlled amplifiers, I can use one for the left and right channel of the fadeable input, and I can use the other pair as our volume control for the output to headphones. And then the unity gain input is just a unity gain input. And the reasoning behind that is that if you have other equipment that has stereo outputs with a volume knob on it, you're going to use that volume knob instead of using the mixer volume knob. That's the justification behind it. And it's basically just an attenuator. It's like a heel to your whole entire synthesizer, so you can sit on the couch and just have headphones on and make all your bleeps and bloops. Or you could output speakers or whatever you feel like doing. I'm not, I'm not a cop. but I need to build the whole thing so that I can test it and I can make sure that the audio stays in phase throughout the different stages. It's likely that there is a much easier way for me to be doing this mixer, but I lack confidence in my ability to make a good output to headphones. And I could copy what like Creative Labs, I've got that sound card sitting down there that I could copy, or what Blackmagic does. I've got the Blackmagic video recorder thing. I could look at the audio pads there. Mostly they're going to be digital and then to some kind of an amplification to output. But instead, what I found was a headphone amplifier component that was that specifically. So whoever built that went to all the trouble to make something that works really well on headphones. And so I can just drop it into my circuit, adding a little bit of overall cost to the end result. So I guess I'm doing it that way, just to be a stickler. And I can say, hey, we got high quality audio on this thing because somebody told me it was. That's as deep as that goes. The keyboard is, I need to do something in CAD for the keyboard. Modular Synth VCO. It's a matter of programming. I mean, I've got the whole circuit right here. I never did the second run of the PCB to kind of fix the errors that were in it. But for right now, I'm not really focusing on this. What I really need to get done, what I really need to do is get back to the, what do you call it? The module testing rig so that I can get that to be able to tune the analog modules that I have. And then I can get back to setting them up on my little test stand over here, a little test stand, and I can actually, get them all tuned up and functioning. That is a goal. It's a longer goal because it's taken a long time to get to where we are with all these things. And so I need to focus back on projects that have been looming over my head for quite some time. The M303, I still have both of the M303s, the one that a viewer sent in and the one that Dave left with me. They both don't function insofar as the output from them is extremely soft. I need to do a little bit more circuit analysis on the output portion of those M303s because I don't know what's wrong. I did the fix. I did the oops, you plugged it in wrong fix on both of them, and they're both doing the exact same thing. They just have very, very quiet outputs. So we need to work backwards and figure out what that last stage of amplification is in the M303. Because we've learned what a diode ladder does. We've learned what transconductance amplifiers do. They're not just an orchestra act in Siberia. And I think the rest of it is just op amps. So maybe there's a malfunctioning op amp somewhere. But I replaced the op amps, and so I don't know what's going on, man. I think that's better than it was before. I don't know. I think it wasn't working, and then I did that fix, and then it was quiet. And then the one that the viewer sent in, who I'll have to keep up with that. I need to drop them a line. But they sent this one in and it was broken in the same way, supposedly, and I did the fix on it, and now it's also quiet. So it's like, what am I missing? What am I not doing? And it said, you got to do the whole repair all at once so it doesn't break itself again. And I did. I did that. That was me. I did it successfully. I'm good at what I do. Come on. And it still did the exact same thing. It's perplexing. I'm angry at them. I'm better than this. This is just some Peaslee little audio circuit, right? I should be able to figure this out. I should be able to fix it, and I should be able to laugh at it for being broken. Those are my criteria. And yet somehow this thing has evaded my ability to fix things. I just don't know what it is. So incredibly frustrating. I am very frustrated at it. You guys don't see it as much as I do, but I've had this goose head sitting on my magnet hanger for the longest time. This thing used to hang out at the back of the tray here for my tools, and just got slapped around and broken time after time. So most of it has been thrown out, but I still have the head of the Goose Game goose. This is a magnetic. Darn. Holding on to an armature. It's analog, so it's practically magic. The old gods have shined upon this analog circuit in order to get it to work. I don't know how do they even check these things at the factory, right? And the thing is, it goes into a transconductance amplifier, which is why I wasn't able to poke the oscilloscope into it and see anything happening, because it's not measuring that. It's measuring voltages over time, not conductance over time. It's madness. I don't know why we function in this way, but I guess that's just what it is. It's what it's. But I got to figure out, like, I replaced the final op amp. The final op amp before the output plug is actually a single op amp in an SOT223. No, SOT23-5. It's a 6-pin, rather. SOT23-6. It looks like a little transistor, but it's got 6 pins, and it contains 1 op amp. And I've replaced it with the exact part number. Did nothing. Do we have a bad part? I don't know. It's weird. It's very, it really is pissing me off, because every time I try to have a stream with it, I'm very, so you guys may not, maybe you do know this, maybe it's abundantly clear, although I've heard people be surprised about this, is that sometimes I do very, very little, and sometimes even less than planning for a stream. My plan going into a stream is usually one sentence. It's, I want to fix the 303. And the problem with that, with the M303, is that it has completely evaded me, whereas generally I can think on my toes and come up with something, and we can go in a direction and have something fun happen, right? Usually I'm good at doing that. But with the M303, it just completely and utterly shut me down. There was no hope. So I don't know what it is. I'm usually more clever than that, but it's just something isn't clicking with it, and I'm not finding the fix. So I need to, maybe I need to just sit down with it and test it a bunch. But that's where the module tester comes in handy, because then I can have the module tester put out a pulse and a waveform, and measure what's coming back out of it, so that I can get it in tune, and so that I can get it make sure that all the features are working, because it needs a little activation pulse, as well as it doesn't need input audio. It needs a 1 volt per note signal. But you can also put your own audio into it. And so that's what I did, and it has the same results. It's crazy. Of being too quiet. I guess this is a thing with these things, because, I don't know if they repair them anymore. Oh, that's Burn the Subs. I must have knocked into this thing. What's up, Omar? I must have knocked into the camera. Yeah, here we go. Come on back down to earth. Here, try to aim you guys at something better. The pile of my failures right here. Get this out of the way. That's black filament. I'm hoping that I can use that to build the flap wheel display, but we haven't worked on that a lot. I haven't put a lot of extra thought into that yet. There you go, the monument to my failures. All these projects that I haven't worked on. There it is. That's the M303. Non-functioning little bastard that it is. Let me get the video to look better. Holy crap. It's all blown out. Oh! Actually, we could just run the automated thing on it. Setup. This would be Burn the Subs procedure. There we go. Did that actually activate it, or I didn't get to see it? I didn't get to see it. All access past 2018. What is that? I don't get why people can't reconcile what it means to not be streaming yet. Because people have like a big problem with, where are we? White balance should be towards the 43s. I don't know. I don't know if these cameras are adjusting anymore. Oh no, you know what? Because this has very warm lighting on it, I had to tune that down. Put the gain up. Exposure at 5. Whoa. I don't know why it looks so washed out. Oh, it's an Overwatch thing? Some competition? Gamer stuff! Alright, let's turn the gain somewhere around there. Yeah, there you go. See, it does work. There are people who genuinely don't understand that, like, I'm not working on a project right now, so the stream hasn't officially started. It's very strange. Well, you know, these days, I guess there is no bottom floor for stupidity, so I should expect anything. But it is kind of weird how people don't get it. Well, I mean, stream intro can take up to an hour. I try to cap it at an hour, but it's time for me to just let people filter in. Interesting thumbnail picture. It's an eye-catching and curious. Oh my goodness. It's the subject of the whole thing. This is the, yeah, the YouTube, making the YouTube thumbnail is this extra thing that I'm doing now before every stream. Because it just looks a lot more professional when I do it. I do these professional things and I see no result as for my extended efforts. And yet people go live with like their headset microphone and get 500 viewers. There's no justice in this world. There's no justice in this world. It really isn't. The number of streamers I know that do a little intro at the beginning where they have like a fixed splash screen up. I got this from Red Letter Media's streams back in the day. And it wasn't a unique thing. I know more than a handful of streamers that do this. The alternative to this is that I simply put up a splash screen and ignore you guys for a little while. Some streamers have a countdown, but all they're doing is sitting there with their dicks in their hands waiting for the countdown to stop. So I'm a little bit more genuine with you guys. I actually want to have a conversation ahead of actually doing the thing that my stream says we're going to do. Sucks I'm an idiot. It sucks to find out this way. As long as it's not the splash screen that is the fixed image for when the stream isn't uploading at all. If there is a screen up that has a countdown on it, they chose to do that, right? They chose that. Oh, I wanted to put this Donkey Kong away, this Donkey Kong connector, but I put all the garbage from last stream on top of it. I'll put the thonk up here. Well, there's already a thonk up there as my example thonk. Just carefully, I don't want to dump this thing out. Don't want to dump any of this stuff out. They're all a floating mess. All right, carefully now. Well, currently I can't count anything on this. We have to take it apart and figure out how it works. I could make this into a stream starts countdown. Actually, it looks like shit when I put it up to... The cameras do not like it. They don't like the dark screen on this. What's up, lines and squares? I don't know what these were from. I think they were... Oh, no, they were from Motor Stuff. Yeah, these are like nice bolts. These are nice ones. I gotta put them somewhere. It is Nixie's, and I would... The number that I had on it on the thumbnail, I would have preserved all the way through the intro, but I was pointing to something and my finger brushed this very, very light button that zeroes it. And so it zeroed it, and now I have no means by which to change it. I don't want to just tap these together to find out which one changes the value because I don't want to blow it up. It's possible that I could maybe send voltage where it shouldn't go. But these, there's one pin that you apparently send pulses into, and it'll count the number of pulses. I think it might be 2 pins. It might be up and down. But we got to figure out what that is. So we got to take this thing apart and figure out what's what. And then what I'd love to do is make something that just plugs into the plug. It'll not with the cable. We'll plug it in directly to the back of the thing, and then that'll make it MQTT enabled. Is it Nixie's? It is Nixie's. And so when you watch it counting, the numbers are actually moving in 3-dimensional space. That's why the thumbnail is such a good image. This is the thumbnail. And it shows it with the numbers in sort of displaced from one another. They're sort of in and out. Pretty cool thing. I don't like this mix. Why are we listening to this? It's got too many like hallucination noises in the background. Do like an old one. Like a Halloween. Ah, it's an advertisement. Run for the hills. I'll just mute it for a second here. That's a 30-second advertisement. Jeez, that's a lot for you guys to tolerate. I mean, it is, but it also kind of isn't. All right, 30-second advertisements. Man, 30 seconds is a significant amount of time sometimes. All right, there we go. It's a little better. Yeah, I should probably unplug this. Let's do that. At some point in time, I would have remembered what the identities of the different color of wires are. Oh, really? I talked about the thumbnail a little bit. I talked about basically how I've added the thumbnail, and it's another thing that I got to do in order to make this seem like it's a slightly professional stream. And yet, for my efforts, usually nothing happens. The more professional I make the stream, it doesn't pay any dividends for viewerships. You had to reboot your whole machine. Oh man. Streaming teaches you to be a little thrifty and try not to reboot the machine to solve all the problems. This is a digital readout. It's supposed to receive pulses from measuring equipment that's on something like a milling machine. So when you move the table or you move the head, this number would represent the precise distance. That's why it's got a decimal all the way up here. I'm sure the decimal moves, but we need to figure out how to take it over. And we can do that with pulses going into this cable right here, but I don't know what the pulses are or where they go or what the properties are going to be. So we got to take this thing apart and figure it out. I could probably look it up. Maybe I could look it up and actually figure out what that pinout is. It is a pulse counter, but it's really for measuring distances. It's just, we don't have the thing that measures the distances. I don't have that. What year is this thing from? Bo Keckler Instruments. Tucson, Arizona. 117 volts. That's a very specific voltage input. Let's see. I don't see a year on anything. Maybe there'll be a year inside of it. We'll figure out what year this thing's from. Probably from the 60s. Looks like it's been made in the USA. I don't know where it's been made, but it's been branded by quite a few USA companies. Park LI New York. And then on the back there's a Tucson, Arizona label. This is a COM connector. It's a COM port. It's called a D-sub connector. It's a D-sub connector, and it's the COM port connector. It used to be that you would be able to plug into these wires here and you would have a direct TX and RX directly out of your computer. We don't have COM ports anymore. We don't have LPT ports either. Everything is USB, and so you have to get a USB to COM port adapter. And there was a lot of controversy in that, in one company kind of owning the whole thing on the virtual COM ports and charging $14 for their chip. And so Arduino started out with that chip, but then moved away from it. And you had people like, you had places like SparkFun doing a programmer that's separate from the actual microcontroller because of this reason. So you buy one programmer and then you plug into these TX and RX pins and you're able to load your Arduino firmware onto the micro. Yeah, and the thing about the back of the computer, there was a larger port on some computers that plugged into the sound card, and that would have analog inputs, which were also used for potentiometers. Because remember, if you put a voltage and ground to a potentiometer and it wipes back and forth, it'll create a voltage between those two with a resistor divider. So what you do is you have your joystick and it has some buttons, and so those buttons go to their own digital inputs, and then you have those analog inputs from your sound card that will take in joystick inputs. And so that's how you have a joystick. The 15-pin D-sub connector was a joystick input, MIDI output, and some other stuff used it as well. But that was back when the physical computing side of computers was much more tied in to the whole experience. It was kind of crazy. But yeah, you used to have a COM port at the back. You used to have maybe a MIDI port in the back. You used to have an LPT printer port, which is just a giant COM port. It was crazy times back then. And then, of course, you went to PS2 for mouse and keyboard, and if you touched that cable, it wouldn't work, and you'd have to restart the computer. That was the coolest part about USB, was you could unplug your mouse. It was like the Wild West. Oh my God, I can unplug my mouse, or the mouse doesn't have good connection. Let me plug it into a different USB port. And it was just, okay, cool. Like, I'm ready. I'm a mouse again. But with the PS2, it was like, oh no, I've got to shut everything down because I need to unplug the keyboard. Now I've got like 4 mice plugged into a computer and it doesn't care. Whichever one moves, you're going to move the cursor. But then, you know, people would use the D-sub connectors for other stuff. And so this is other stuff that uses the the COM port, the D-sub connector. This is other stuff that uses it. The D-sub connector is a wonderful piece of engineering. It is old, it is big, it is clunky. It is like an AK-47. It's like the AK-47 of the computing world because it is old, clunky, but very, very functional. The D-sub connector can handle what is it, 5 amps or something at 12 volts on each one of its pins. It is absurd. Its safety is like 1 amp to use on the pins, and so if you have a D-sub on your device, you can really run a lot of stuff through it. It only plugs in one way unless you are destined to break everything you touch. It also screws into place for a little bit more reliability. You can kick it with your foot and it will still stay connected most of the time. Do you have a D-sub serial mouse? No, I do not. USB ASP is what I use to program AVR. Made a jig for it using the AT-Tiny 1634. Yeah, and the thing is, because of the prices of those virtual COM port devices, people got real clever real fast and actually phased out the whole COM port thing fairly quickly to go directly from USB to the microcontroller. Some of the better micros out there do that automatically. And of course, in doing Arduino stuff, you know, all the companies wanted you to buy this, like back in the day, you'd buy a $300 programmer, and that would allow you to program the microcontroller. And it's like, are you guys trying to keep this secret? Like, why is the hurdle so high? And so Arduino kind of, well, the basic stamp changed that up, but then the Arduino kind of fell in its footsteps and made its sort of own brand of very simplistic it was kind of like a veneer over the deeper layers of the microcontroller garbage, where you don't have to figure out what all your setup flags are. Because the setup flags are for advanced users, right? But they're the first step in getting a microcontroller to work, which was the schism between the people who wanted to do the cool stuff and the people who were dedicated enough to get to that point of being able to do the cool stuff. Arduino put a veneer over all of that, and so you could just program the chip. It's like, that's the star of the show. You want to just get that thing, churning away at your code, because then you start to realize the possibilities and go, wait, isn't this thing limited? And you go, ah, but it's one of the setup flags that you can change. And you go, oh, there's a whole deeper layer to all of this. It's like, it's there when you need it, but when you don't, it's just pure mind to physical thing. That's what's so cool about Arduino, and why I still advocate for it to this day. It is just magic. It's pure magic. And if you don't know something, somebody has done an Arduino project about it. Hell, there might even be an Arduino project for this thing. It is just that versatile and cool and accessible. I know artists that I've had to recommend about programming stuff because they wanted to get that extra, they wanted to put a brain in their art. And I think that's just the highest calling of any engineer or artist is to sort of blend the lines, you know? I love it. I love it. Are the pins on those connectors standardized? Maybe you can get some clues or advice on that way. I'm not sure. There's all kinds of things. Like anyone and their dog has done something with D-sub. I know that some pipe organs use D-sub connectors for all the solenoids on them, right? Anything goes with one of these connectors. And since this is a weird device from a bygone age, I don't trust anything about the pins of these. It might be 5 volts. I think it's probably 5 volts, but it might also be 12. How should I say it? Arduino. Do I need to roll my R's when I say it? Is that gonna be okay for you? I say solder, I say Arduino. You get used to it. I ain't changing for you weird Europeans. Give me this seltzer. Ah. We don't add consonants to crap. We don't say aluminium. It's aluminum, actually, is the original one, but we don't say, we say aluminum, aluminium, Those are all the same thing. It doesn't matter. But we don't say titanium. Freaking jerks. You guys called it soccer and then switched to calling it football. But we had soccer and then we had football. And now you say we call it footy tooty. How could you be so uncivilized? And you guys talked in a southern accent when we came over here. And then you fucked off and you started talking all fancy. It's not our fault. Learn some accountability, European people. You haven't even said sorry once. God, that's such a national embarrassment. I fucking hate this. But anyway, yeah. You sing titanium. How do we? I mean, we do sing in a bit of a British accent, don't we? I'm not UK, I'm USA. Listen, I don't shirk from an opportunity to go on that rant. It's not for your benefit, it's for them. So they know their place. Do you ever do that thing where you add at the end of a word? Maybe. No. 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 I never thought I said Arduino wrong, but apparently it's not good enough for chat. I never heard it pronounced any other way, and I've mostly read the word. That's one thing about like pronunciation stuff. Somebody pronounces something wrong, I'm totally happy to correct them. But I don't hold it to them in any way because it's like sometimes you just read a word and you think it's something else. That's happened to me a lot recently, is finally listening to something actually get pronounced and you're like, oh, I got that totally wrong because all the rules of the English language are all juxtaposed against one another. Like Aaron earned an iron urn. Earned an iron urn. An iron urn. Aaron earned an iron urn. Arduino. Is that how I should be saying it? Should I be rolling the R? How did the settlers pronounce Risk V? And GIF. What did they say? How do they pronounce GIF in the 1800s? They say GIF? Or is it in old English and it's Kenish? Kenish. Ah, Kenish. Wire. I love speaking in old English. I don't know how to do it though. When I have something to say, it's just a lot of fun because you just get to basically do my comedy Dutch accent. It's good fun. What's up, Matthias? Risk V is objectively wrong though. Oh, I should go RISC-V. Pronunciation depends on region where you live mostly. Language is made up, no worries. Yeah, I mean, honestly, you guys are barging into Philadelphia, so you're gonna have to deal with me pronouncing things the way we do, like water ice and go down the shore. I don't know what else we have. We got a lot of those little things that are sort of in my vernacular that would have to be surgically removed at the cost of the life of the patient. So I talk the way I talk because I talk good and know good grammar and pronunciation. I'm good at this. But anyway, I try to keep everything clear, but you know, if I like mispronouncing names and getting your names wrong is just for fun. Yeah, it's all good. It's all good. Don't worry about it. I don't blame you guys for anything that I do. DH gate. What? Huh? Adhesive medical strips. What am I looking at? Hold on, I gotta open it in a different window, which is always a pain in the butt on this setup, just because of the way Social Stream deals with that. Magnetic linear scale reader, 5-volt TTL. Linear scale reader. Yeah, these do often use D subs, and actually my DRO on the mill, my LED one, does also use this type of thing. These are expensive. Usually they're not so expensive. It may be an old pinout that still uses the same pinout. I might be able to plug this into my glass slides and have it work. Oh, it's in the images? Oh, hold on. I gotta open it up again now. We'll verify it though. We're gonna take this thing apart regardless of whether or not it wants me to. Regardless. 5-volt DC. Down below, where am I seeing the pinout? I ain't seen no pinout. Looking through the images. Plug pinout is lower in the images. No. I don't. Maybe my browser's blocking something. Yeah, I don't have this on my page. Weird. Oh, view more. Where's view more? This is like, how do I read a PDF? Specs, description, view more. Ah, there we go. Okay. I found it. I found the button that I have to click that unlocks hidden knowledge kept secret for centuries. Here it is. TTL signal output default. 0 volts A, 5 volts B and Z. This would be a sign encoded with a Z, which would be an interesting way to do things. Sign encoder. Which means you just have 2 waves and then you have a Z. I don't know about the ramp Z, but usually it's like a pulse. That means you've gone 360 degrees. I hope we don't have to replicate that. Analog output from microcontrollers is still kind of a cursed thing. I guess we could do it. But yeah, the way that it does your A and B phase do that. There's also this kind of AB encoder, which I think may be what we have, but the fact that the thing moved so erratically when we did tap the wires together could indicate that we have an analog AB that we have to go through. In which case, I would like to tap this thing a little later on to where the TTL stuff is more precise, and we can get the numbers that we want to get out of this thing instead of having to fake a level of precision that an AB encoder might have. We can instead invoke the numbers out of the digital parts, the more discrete parts of the circuit instead of the analog parts of the circuit. Calling out your name. What are my slides? Hold on. This is dangerously close to what we were working on air. HXX. Let's check. I thought somebody was yelling outside of my house, calling out your name. HXX encoder pinout. Yeah, this song is a little whiny. This is the exact pinout that we were just looking at. This is the exact image that we were just looking at. Oh wait, but it's a little different. It's mirrored. Hey, I just saw it. I just saw it. What the heck, man? Yes, the cowboy meme. I was just looking at it. You just hid that from me. All right, we'll just go from here. Oh, here's different ones. Reference mark every 50 or 100 millimeter. 0 volt, A, B, 5 volt, and Z. A minus, 0 volt, shithead, Z minus, A, 5 volt, B. Does it say shield? Shield. Oh. Yeah, Google just has something that's been gone over by a bot, and AliExpress pulled the listing because it's old. But it looks like this is one version of the 9dB socket. There are different versions of it. I'm seeing multiple different standards, so we don't know which one we have. But it did, by the jumpers that were hooked up, it did look like we had something. But if this is 5 volts, that's perfect. We can power our Arduino with that. And so I can throw it either internally or just have it plug into the back. But I don't know what type of AB this thing gets, if it's analog or digital. It's likely going to be this, which is like, well, what is one number indicate on that? How do I move that in order to change one number? So maybe we have to take it over a little bit more internally, because somewhere after, there's going to be some section of this thing that is decoding that AB sinusoidal wave, and then after that, it's going to be invoking numbers on lines, and that's maybe where we take it over. Good stuff. This is good stuff. Good stuff, good stuff, good stuff. Wonder if there's any way, Vile, that's a serial number for the chip to identify itself. Oh yeah, of course. Look, we'll get there. We'll get there. This is very easy. This stuff is great because everything inside of this thing is discrete components. It's not like, we're not going to get like an ASIC or something that's not labeled. Because this is built in America. We don't have time to friggin' sand off numbers. Because we're not, whiny little sniveling assholes that think that somebody's going to copy all of our chips. Built this to last. It's made out of metal. It's supposed to be in a machine shop, chugging beers. So it's built with everything like spread out. It's awesome. The manliest of machines. I had leftover Chinese food for lunch. Where's my blood glucose overlay? Which scene has that? I think it's this one. I need to put this to a button. Oh, where is it? There it is. That's actually not that bad for having to, I made sure to portion correctly. Chugging beers and machining blocks of aluminum. You really should not be anywhere near alcohol if you're doing machining. It's really not a good combination. I'm gonna do this cut. Just explodes. Yeah, and particularly not firearms either. Those are both machines that just do not give a crap about your well-being. You are the softest thing in the shop. You're like a big puddle of pudding to these machines. All right, so we got partially started here. Seems like we might get through this a lot faster than I had anticipated, but we'll see. Let me get the music out of here. Lubricant for machining aluminum. Alcohol's not great at doing that, let's be honest. You want like an oil. You want like a light machining oil. An American cheese is meat lubricant. It is designed to allow you to eat meat faster. All right, start soon is out of here. That means if anybody says start soon, it's not going to petulantly get giant on the screen, which is something that I was able to do in Node-RED. We are going to be using Node-RED ESP8266 as a Wi-Fi Arduino, very simple, cheap one, to take over this thing. This thing is a digital readout, DRO, for a machine of some type. There are these rails. There's several different kinds of rails that you can buy, some even spinning encoders that will translate motion into something that gets read by the machine. We were talking about it a little bit during the intro. There are different types of encoders. Typically, you would see a wheel encoder that has an A output, a B output, and a Z output. The Z output is designed to tell you when the thing has gone 360 degrees. The A and the B are two sine waves that are a little bit out of phase with one another that describe the position of the machine. So you have all of these unique A and B values that represent where on that 360 degrees of phase that you get from rotation, where in that you are. And depending on the hardware that's looking at that A-B encoding, it can be extremely, extremely accurate, or it could be digital. We've found a couple different standards. Sometimes you pulse A and B in a particular way in order to clock up the position, right? And then if you're doing like encoder from a knob and it's going into a digital system, you would have an A and B pulse that would indicate what direction the knob is moving in. This is not the turbo encabulator. This is in fact not gibberish. I am talking science. I am talking the science of measuring precise locations in rotation. And you can linearize that rotation, which is essentially what's happening with the standardization of these glass position sensors on my milling machine. This is a more modern DRO. It's kind of an old design, actually, to be honest. I think like the newer DROs are probably like way cooler than what I have. And I think there's a little bit of hardware that can make you have a DRO that's like on a tablet, and then you can like do all the math you want to do on it. Kind of cool. This one's a little bit more old school. It's like a giant pocket calculator, and it's got all of the different number displays on it for X, Y, and Z. And then of course the whole setup for the DRO is like $300. But I've got these glass slides. The yellow thing is back there. It's a glass slide that tells the position of the different pieces of my milling machine, and that translates into very precise limitations on the movement, I guess, is what I'm talking about. Because you can machine something to specifications to the right numbers, and you can make a 1 inch by 1 inch by 1 inch square, which I have. It's sitting somewhere over there. So that's what these do. These are basically just number displays. But way back in the day, they were not like us. They did not have number displays that were digitally readable. I mean, you would have like gauges and stuff like that that would mechanically move, but if you wanted to electrically display something, you were kind of SOL on the types of displays that existed. So there was a brief amount of time where between mechanical displays and electrical displays, we had these things called Nixie tubes. And the Nixie tube is simply a bunch of neon lamp plates that are stacked on top of one another. I have a bunch of those things because I am a modern engineer who does entertainment, and these things are ridiculously popular with that crowd. So basically everybody probably already knows what a Nixie tube is. I've got a bunch of them in here. Several of them are broken, and somewhere at the bottom of the spin I've got all the different plates of a Nixie tube. But if we're looking at these are the big round ones. They've got this nice giant old school looking display. They have a certain aesthetic to them, and you can see, don't really need a microscope for that, but you can see that it is a bunch of numbers that are stacked on top of one another. So there are parts of the numbers that do get blocked when you light up the displays, but it doesn't really matter that much because you just move your head around and you can just see what the body of the number looks like. I mean, we can see that very clearly that is a 0, even though there's stuff crossing in front of it. A new beige fire hazard machine. I've had this for quite some time. I don't know if you maybe missed the original stream. It was some holiday or another. I sort of flippantly told my brother, just get me something weird that's electronic. And he came up with this, which is pretty cool. I don't know if maybe he was like eyeing it for some time or what, but this is a digital readout, and it has just all of these numbers in a line. The cool part about it is that when it counts, when Nixie tubes count, the numbers are in 3-dimensional space, so they actually move forwards and backwards. It's really cool stuff. We're going to take this over with an Arduino, which is a fairly trivial process. We just need to figure out where we're taking it over. He chose a good gift. Yeah, it's pretty cool. So I don't know if this thing, because this is from like the 60s, right? Nowadays we have like LCDs, we have LED displays, we have all this other crap to display numbers with, but this is like the 60s, early 70s maybe. Pretty crazy. Smells like RS-232. It is not. It is in fact, this is its own, this is not a COM port. It is a COM port cable, but this on this machine, this is actually, and we learned this just a moment ago, it is actually some kind of encoder standard. So it's an AB encoder. I don't know if it's sinusoidal or if it's digital, but we have 0 ground, A, 5 volts, B, and Z. So it's probably going to be some type of encoder, and I don't know whether it's digital or analog. Might be analog, but we're going to find out via the circuit. We're going to take a look at what the components are in this thing, because they do, you know, this is before the days of the microcontroller. They don't exactly have like a basic stamp sitting in this thing. This is going to be all TTL logic and, you know, easy to look up stuff. Let's see. Boop. All right. Yeah, that's what I said. I said that already. All right, so what's up, Make Mistakes? How's it going? Yeah, so I want to take this apart and I want to give chat the ability to count numbers on it. Since we've got 10,000 numbers on this thing, we can display some pretty big numbers. And if I give you guys the ability to put like a plus sign and then a number, then we can add up on this thing. And I could even add subtraction to it too. We can work with I think this is still within the size of an int. So one singular integer we could potentially display on this thing. Let's take a look at what everything does inside of this. I'm going to power it down, and so all the capacitors will be nice and charged with 117 volts. It's very specific. It says 117 volts on the back. Power it off, and let's get inside of this thing. Let's go spelunking inside of the machine, chat. We got a little bit of latent heat from whatever the voltage regulation is going on up here. It's not exactly a 7805, not in this era. This stuff is chunky. It's all very chunky. This input is not used. It looks like the second level of stuff is not installed on this, which it's a little disappointing that we don't get two readouts, but I mean, beggars and choosers and all that, you know? Where's my focus? Hold on, I'm on the wrong page. Arm focus, there we go. All right. So yeah, back here we have the service plate. Beckler Instruments. I don't know if they're still around. They're in Tucson, Arizona. And then on the top we have the seller, who is Stangert in Long Beach, Rhode Island Park, New York City. That is a lot. Long Beach. Oh, Long Beach Road, Island, Road, comma, Island. Not Rhode Island, Road, comma, Island. So we've got upstate New York. Or no, LI, New York? Yeah, I don't know. I don't know if that's upstate or not. We got New York. We got Arizona. And then we have the Beckler Company. I don't know where that is. Let's get this out of here. So this is the number of pins on a COM port, right? But they decided to take those COM port pins and make them into an AB encoder because, again, these cables were ubiquitous. They're easy to find and they work really, really well. I was saying earlier, like, pipe organs use D-sub connectors. They are ubiquitous. You can get them from Radio Shack. They carry about an amp on the pin. More so, you can push it a little bit beyond that, and they're just dead simple and easy. Aircraft use them. I would imagine they have some pretty intense locking mechanisms on them for aircraft. But again, like they they come with the screws and everything to lock it down so it doesn't unplug during production. You can kick these ports and they will continue to function. It's amazing. D-subs are some of the best, I think some of the top human engineering that exists. How is this thing held together? These look like rivets, but I think they are screws. These are rivets. And this is active. I should unplug the active power thing. This power cable fills me with dread. Look at how close those are, and that's at 115 volts. That is just dangerous. That is a bad design. This is a bad design. Bad design. Holy crap. You could put your tongue up to this for a good time. Oh my God. That is nasty. I'm unplugging it from the wall. It feels like a vacuum cleaner power cord too. It's one of the ones that are ribbed for her pleasure, and it's super duper flexible. This reeks of house fire. Is the wall plug polarized? It's a 3-prong, so you can only plug it in one way. And our load and neutral are on the 2 pins there, and then you have the additional ground. So I forget which one is which. I think the left one is load. Sometimes these are labeled. Yeah, on the more modern plugs, this one has an L, I think. No, that is 1. Sometimes embossed into the plastic, you get the labels on it. And on the NEMA connectors, the ones that go to the back of the computer, they're also labeled on the connector itself. It's kind of cool. After a certain time, they started making the neutral larger. This is not that time. Yeah. Yeah, the plugs have a slightly larger neutral. 1975 is when that was mandated. No NEMA, no larger plug. That's why I said 1960s. Well, that's not why I said I didn't know any of that. So I had to know the information if I was going to say that's why. That's not why. I was unaware. All right, I'm just kind of dawdling a little bit here to hopefully let the capacitors kind of run their course. I think this is held together with hex bolts, which is really weird, especially for this sort of era, putting this thing on the map. All right, let's get these over here. Oh, that's kind of cool. The company evolved into manufacturing microscopes for lab work that are also computerized. Huh. That's a niche, but an interesting one. Oh, that was burn the subs focus. That's going to be, okay, that camera's going to be out of focus. Hold on. Make sure we focus there. Okay. There we go. Try turning it on now that it's unplugged. I wonder if we get anything out of it. That's a good idea. Oh, good. It's not one of those. Sometimes you get just a little breath of life out of it. Yeah. I don't know, the neon tube, if you don't get it to actually produce plasma, is there a discharge through it? Because it would just be 2 plates hanging out 6 feet apart. All right, so we're getting into this thing. The reason that we're getting into it is because I want to figure out how it makes the numbers, and we want to figure out what the pinout of our encoder is. It may be standardized, but again, we're dealing with something that's so old that it might predate the standardization. Although by all means, it might not. They make top quality equipment. Oh, geez. I always thought it would be cool to be one of those kinds of things, you know, the real specialty kind of machine, like electrical doodads and machine stuff. It's sort of in part akin to my love of niche RF equipment, where like you have somebody that needs to test whether or not an antenna installation works, and they buy this one particular doodad from this one guy that sells it out of his house somewhere in Arizona, and it is a box with a resistor in it. That would be super duper simple to build yourself if you knew what you were doing and you could certify it. Look at the size of this motherfucker. Oh boy. That's why are we stopping? Calling out your name. We're stopping midway out. Where are we stopping? This is a massive capacitor, a big capacitor on the end of this thing. I think maybe something needs to unplug in the front first before it allows us in. Let's check the front. The front butt. Yeah. The death beam. I am not going to be touching that. By volume, monitor caps are much more potent than they used to be. It's probably a fairly small value. I mean, you wouldn't even need to design this thing to have that big of a cap nowadays. I could take all that out of this and just put a wall wart in there. Yeah, I'm still going to treat it like it's got my lunch money. These are some real rusty screws. I don't know where this thing was housed. 100 UF 50 volts. That's like where did it go? I had that cap sitting right here. Whatever. Yeah, it's like this. This is like 100 UF 50 volts cap. At least it didn't suffer from the electrolytes like drying up. Whole farads were a dream back then. I had some multi-farad caps at one point. They're these massive things. Actually, hold on. I think I can find one sec. Let me just go. I'm gonna go look for a capacitor, Chet. I think I got one back here. We got one. Let me see. No, I must have lost my giant capacitors. Usually they sit on this curiosity shelf. Now, they might be upstairs. They're these big blue chunky things. I once asked on a forum how to charge them, and they were like, be real careful with it. And I tried to charge it and then discharge it. Nothing happened. I think it was a dead, but it was like this big. Is it over there? No, it's not over there. Okay. I got to look to all the places that I put curiosities in the shop. I try to fill the visual area with things. Just a great application of a button, guys. Really, really appreciate what you guys are doing out there. Soldering it directly to the board. And it's just like a little Radio Shack button. Kind of amazing, actually. But they attached it directly. Let's get this thing out of here. Open the doors. Get them out of there. Try to keep this together because I want all of my similarly crusty things to exist together. They seriously use shrink wrap on each pin of this. That's nice. Built to last. But then they didn't give it a plug. They didn't give it a plug in there. That's ridiculous to me. Added JST. I don't, this thing is functionally, I guess it's not really an antique, but it kind of is an antique. So I don't know how much I really want to modify it. Oh my God, the whole thing plugs into itself. And it's got exposed traces. Jeez. What the heck? Oh my God. This is the most seriousest power supply. Everything is big and clunky in this thing. Okay, where am I putting this? That's super cap. It's just very big. It's just very, that's all it can claim. It is just a very big capacitor, that's it. Oh my God, just get an Arduino with an LCD. Sheesh, what were these people doing? You could have just used an Arduino. So the serial input and the power are all coming through that card rack. Measure what? 4038 BP. All right, don't do that around capacitors. They don't like it when you fart. It's a GE, General Electric. 15 volt DC, 9,200 microfarads. 9,200 microfarad. 15 volt. Hold on a second. Hold on a second. Okay, so it's hard to find. Let's do like capacitor. We'll do through hole electrolytic. Through hole. Just go with the value, I guess. Capacitance, scroll down. 8,500, 9,000. We're over 9,000. 9,300. Let's go to 93 instead of 9.2, motherfucker. 9,300 voltage. Sure, we'll look at the 50 volt version. Let's apply that and see what we get. They're pretty big. It seems like they're pretty big. This would be a direct replacement, I guess. No, it's a U, yeah. Imagine blowing that thing up. I'd rather not, because it would constitute grave bodily injury to your streamer. 85C Max, made in the USA. But it seems like I could source a replacement for this if I really wanted to. It's covered in aluminum, that's why it looks so crazy under the thermals. The thermals are having a field day with it because not only is there a little bit of latent heat in the area, but also because it is just reflecting all of the long wave infrared. Yeah, it's true. Maybe the fact that people are replacing these guys in devices like this would mean, and similar, would mean that you'd want something that's the same size because maybe it's got a clamp on it. And you want to make sure that that cap is clamped in a whatever environment it's going into. Yeah, that's true. That may be the case. This is interesting. We've got wire jumpers that go directly into this. And we've got some kind of, oh yeah, this is the full wave rectifier. The full wave rectifier is bolted to the outside of the case where it gets a heat sink on it. And it's just got shrink wrapped wires that go down to the exposed copper board. It's a coated copper board, but still giant. The transformer's why my hands are tired. What is that one? That one's not a rectifier. What is that? Big 3-pin device. Holy heck. Yeah, say they don't make them like they used to, but damn. This thing is big and in charge. It's crazy. I don't know why you would bolt a transformer of this size to your circuit board. I guess, okay, so there are brackets on it too. Yeah. Chat, be on the lookout. When we have something like a DC power supply that's being fed AC, there's gonna be a rectifying capacitor. And usually that rectifying capacitor would be larger than the other capacitors on the board. So keep an eye out for something like that in the power supply, and maybe we can identify where the power's coming from. I don't really see anything that could potentially be a gigantic rectifying capacitor anywhere on this board, but it's there. We'll find it. Jeez. Yeah, these little guys over here, they're capacitors, but they've got color codes on them, which used to be a thing. If you've dabbled in old electronics as much as I have. I don't want to ruin any of my conductive implements. I don't want to melt the end of a hex key, so I'm not going to touch anything to those terminals. I really just don't want to mess with them. I just don't want to mess with them. We've got several taps on this transformer too. No less than like 6 wires coming out of this thing. So what kinds of voltages do we think we're seeing on this thing? I don't think we're going to see 5 volts necessarily, but we do know that the original COM ports would be talking 5 volts. The question is whether or not these follow any kind of standardization. And they might. There's a good chance that they might. So let me put this down before my arm gets too tired. I'm a little, I don't know about running this thing like for a while in the shop, because I don't know if I trust any of this stuff to do to not blow up. And we have Nixie running electronics here. These are smaller than I thought they would be. I don't know why they look larger inside of the actual thing. The pinout I had said 9 volt. That's not relevant anymore. That's not relevant anymore. That's not relevant anymore. That's not relevant anymore. Let's jump in a little bit here. One of these is my... Oh, it's on the other browser. I'm running multiple browsers. Yoink. This one says 5. This one says 5 volts. 5 volts. I wouldn't doubt that it would say 9 though. The older standards go higher up in voltages, so. Yeah, I didn't see any 9s, but I'm going to be wary of them. We'll put it up to the multimeter before trusting anything, because older electronics, you know, there weren't as many standardizations when they built this thing. Crazy design though. 4038 is written in there by hand. We've got RGM1A. We've got some bodge wire repairs going on the underside of this thing too. Transformer ratio. Hold on, let's take a look. Risk my bacon again touching this thing. I like my bacon, and I like it where it is. I don't want it to be blasted out of me with high voltage. I get 5804 on this thing. That's all I get. 5804. I wonder, there's probably a repair manual for this thing sitting in some dusty cabinet somewhere that'll have a full schematic. So these are smaller Nixie tubes. What is this one doing? This one has XYZ plus and minus on it. Interesting. So I guess if you had the higher model, you might be able to actually illuminate some... Oh, these are just a big grid of pins. Huh. Grid of pins going directly back to these guys. Then I believe these are counting. We've looked at this before, by the way, chat. I've looked at this before. I just want to get into it a little bit more. 5804, a date code. It's the 58th week of 2004. This was manufactured. Of course. Why didn't we see it right in front of our own eyes? Whoa, look at that transistor. Oh my God, eat your heart out. Whatever package those other ones are, the D-shaped ones. It's like a little water cooler. It's got sort of a nubbly top, and then the pins just come directly out of the bottom there. We got some old school diodes. If you guys have never seen a diode before, some of my chat is younger than some of my shirts. So I have to say, like, whoa, what's that clear looking device right there? That's a diode. That's what diodes used to look like. They were glass encapsulated silicon junctions. And so you have the raw silicone right in there inside a glass. And these things break like you wouldn't believe. Reworking something that has glass diodes in it is just obnoxious, because you'll desolder one pin and start to move the part out, and then it cracks the diode and it's dead. But yeah. There may be germanium. I don't think they like it if you talk about them like that. I remember working with glass diodes. I'm awesome and young. Oh, my back. I can't show you guys the fronts of these things because they're on this big, long, tall board. I guess I can do that. I think I skew to a slightly older crowd on this stream anyway, so don't worry, you old fogies are in good company. Although I would like to connect with my younger audiences and not in a Minecraft YouTuber kind of way. But yeah, there's a lot of cool stuff in electronics, a lot of old electronics. If you have personal experience working with any of these chips, maybe you have a doctor's appointment that you need to schedule, because this stuff is old even for me. I need my ear. I've got you on full volume, but my Bluetooth speaker is hooked up to the TV in the other room. My Bluetooth hearing aid, rather. My Bluetooth hearing aid paired with my son's phone. We are going to look up the ICs. The principal tenet of reverse engineering something, figuring out how it works, getting in there and taking it over, is looking at the data sheets, because the data sheets will tell you everything. They'll tell you absolutely everything you need to know about a circuit. So patience be with you. We will get to what you guys are talking about. Try not to remote operate the streamer. We are going to encounter, and again, I've done this before, so I kind of know what's in here already. If you're familiar with the 7400 series, that was a big deal back when I learned about electronics. Back in the early 80s, the late 70s, early 80s, the 7400 series was dominant out there. 7400 series are a bunch of what are called logic chips. So when you have one input do something and then another input do like a 1 or a 0, it's all 5-volt level signals that you can then get sort of emergent behavior out of by arranging them. And now all of this is not going to be logic gates. A lot of these are going to be decade counters and things like that. And so 7400 series logic was a way to put fairly simple working elements together in order to make something that did something complicated. In our case, it's just counting numbers is the complicated thing. That chip looks like it melted in a little bit. It's a little bit weirdly melty. I don't know why such an old ceramic chip is sitting in this thing at that position, because these are all the same thing. It's just like, why would that one be different? Weird. These are probably high voltage drivers for the neon tubes that are sitting in front of them, whereas these are more than likely counter chips. And so these will count up to a certain number, given a train of pulses, possibly from that chip right there. It'll get pulses, it'll count them, and then when it flows over, it'll bump the number up to its buddy next to it. That's typically how these things will go down. We're going to take a look at some of the part numbers, though, that we see, because it seems like there might be an injection point somewhere over here. And again, this board is so big that it's actually, my microscope is not really good at looking at the whole thing, but we're counting over here possibly. And these might be an earlier count. And then somewhere over here, we're turning our AB sine wave into pulses that are sent out to the elements over here. That's my theory on this thing. We'll look it up in just a minute. But yeah, the 7400 series, if you want to mess around with solderless breadboard and you want to do something cool and meaningful with your life, they're really fun to play with because everything is 5 volts. You can just plug LEDs into various parts of the functionality and see it happening. That's the upside of being Santa. I'm no longer old. I'm timeless. I will never, ever, ever live it down that I was at the Philadelphia airport and it was during the holiday season and there was a jolly old Santa guy with all his white hair looks directly at me, just locks onto me and goes, "Oh, you're gonna be a great Santa." And I'm like, God damn it. Like, I don't have gray hair. Not like my family typically doesn't get gray hair until they're very old, I guess. But he immediately identified me as a Santa and I went, I need to lose weight. I was like, oh no, I gotta lose weight. I am not gonna be flattered. No. Give it a couple years. We'll see. I've got some white beard hairs. It's like right. This has gotten a lot lighter. So we'll see what happens. I still got a couple years of me looking young. so we got to figure out what the functionality of this is. It's as easy as looking up part numbers. We can see kind of a structure of this part. We know that these are going to be like 60 volts, so it's going to need specialized hardware to run. I actually do have 7400 series. They're not 7400 series. They're logic level chips that are Russian that are designed to drive Nixies. We have a stockpile of 148 different types of 74 series logic chips. This bin right here, this old Maker Beam bin right there, that's full of 7400 series logic chips, like top to bottom. I bought them in an eBay auction because I got rid of my old ones, thinking, you know, get with the times, old man. The 7400 series is dead. And so I threw out all of the ones that I had, which was really dumb of me to do. So I bought, like, for like $100, I bought all those on eBay just to have them, just in case. He identified your vibe correctly. I don't want to be identified as a Santa. I'm not a Santa. The problem is I think of myself as a weird, what I need to do is be skinny. That's what I need to do. Skinny Santa or anything in between. Okay, so what do we have here? MC836P. We'll try that. MC836P datasheet. Google that. That might be the right one. Jolly old chip. I suppose. MC836. Motorola. And it's like an ad page. Jeez. Okay, let's see. 4 to 5 volts. Okay, so we're 5 volts. L suffix ceramic package case. MC836. A hex inverter. I hate these multiple functionality things. This is a radiation proof package, I think. I think that's what that is. Hex inverter, hex inverter. 836 MC862. You know, I have a feeling this chip catalog is going to get us to this whole thing because we've got all the MC numbers here. EAP32? Oh, ESP32. The 8266 is done just fine for all the functionality that I need to get out of something like that. But I haven't had the opportunity. I haven't needed anything so powerful as to justify the use of such a chip. So I haven't needed it. And usually the stuff that I'm doing with more functionality is like through a teensy. I wonder if we put 74862 into it, if we get the right chip, because this seems to be a Motorola series that's doing the same kind of thing as the 7400. Well, let's see, 862, 8485, 862, triple 3-input NAND gate. So there's 3 NAND gates. And what happens is they are NANDed together. Now, if NAND sounds like a completely alien term to you, that is because it is part of logic gates. Logic gates are if you take 2 inputs, you get something on the output, and is like the basis of most computing technology. Why is my computer going slow? Why did it slow down? Don't do that. Don't slow down. It loaded all the ads and it like gave me frame skips. Logic gates, basically, if you have 2 inputs, your third output is going to change. And in the case of a dual input NAND gate, oh God, that lady slid in on the ad. She slid in from the side and it scared the shit out of me. I thought somebody was walking up behind me. The inputs dictate the logic of your outputs. So in this case, unless the 2 inputs match, you get a 1. That's essentially the logic behind that. Now, when you get into multiple inputs, that's when things start getting crazy. And there's all kinds of rules for, what is that one's going vertically? That's a weird one. So when you have 3 inputs, this basically the 3 input NAND gate, unless all the inputs agree, you get a 1. And there are actually like laws and equations for determining how to reduce the number of logic gates in a circuit. It's all ancient technology at this point, but it is the basis of modern computing. So it's fun stuff to learn, and you can kind of poop around with these things and have a good time. The cool thing about logic and really something called an FPGA, a field programmable gate array. An FPGA, oh, what happened? It went red. Siloroso. Subbing for 90 months. 90. How's it going? What is this? What is this? Who is this doing this synthetic type of alpha beta psychedelic funkin'? That is disgusting, and somebody should be have a stern talking to about what a roux is, because you could make the American cheese into a roux. You would need a little bit of milk. Maybe some flour if you're feeling frisky. Anyway, input, output, right? So the quad NAND gate might have a standard array. Let's see. Quad input NAND, or no, triple. What's the word for triple? 3 input. I guess we'll just do that. 3 input data sheet. I guess that's where these drawings are coming from. So there's how the gates are arrayed inside of this chip. So on pin 1, we've got our center input, 13 and 2, and then our output is 12. So what's happening on pin 12? So this is going to be a big thing with logic gates then. And usually when you do logic stuff, it's everybody gets 5 volts and everybody gets ground. So that's what these rails would be on either side. Yeah, there's a whole bunch of stuff. That's what it's doing. Oh, man. Okay, so this is completely reverse engineerable, right? And it wouldn't even be that much. It'd be a lot of effort to reverse engineer this thing fully. We do need to get a little closer into it and figure out what's going on where. There are just a lot of pins doing a lot of stuff here. I guess we need to get to the bottom of, but it's a lot of stuff. It's all very spread out though. 90 months since you got your badge of internet creator. Yes, I am a certified internet creator. I got a check mark that is actually fairly difficult to get if you're building your audience purely on Twitch. I would like to have built a larger audience though, and I don't know how to do that. I guess I'm just bad at that. You guys know that I'm perfectly entertaining. Is that a relay? It sounds kind of like relays. No, these are not relays. These are logic gates, although they are very similar to relays. And with relays, you have something called ladder logic. And I guess these are probably born from that field of technology. All right. 80s, early 90s. Yeah, I mean, the fact that it uses Nixie tubes instead of just LEDs, I'm not sure. Is a logic gate basically a virtual relay? I guess they can be, they were used kind of like them, like with ladder logic, where you would use a relay to hold a relay closed, and you would be manipulating voltages that are going around in sort of a logical way. Yes, but kind of no, because they're silicon devices. They're silicon devices, and the thing with an FPGA is that the logic gates operate almost instantly. They're very, very fast. And so with an FPGA, you've got your emergent behavior from the arrays of all the logic gates and how you set them up, and you can have a device that is essentially a flow from input to output happening almost at once. It's pretty crazy. It's pretty crazy. It's like a totally different way of thinking, because with a microcontroller, you have what is essentially an elaborate piece of clockwork. And as that clockwork is ticking away, it is going line for line and performing simplistic instructions. Whereas with logic, you would assert voltage levels on one side, and then due to the way the logic is arrayed, it will assert something else on an output. It's like a different way of thinking about doing tasks. My Amiga 1000 RAM board got some color and shine to traces, and it's Rev 0.8 from 1984. Well, but the thing is, this is a small company making a DRO. This is not like Amiga. This is not like Sony or Nintendo or something like that. This is something that somebody drew, maybe sent off to a company. Maybe they made the circuit board themselves. I mean, they did manufacture these, but not at such scale as like Amiga, right? So it's gonna have quality differences. It's gonna seem like an older thing. Oh no, there is no solder mask. This is if you lick this board, you will get a little sparky going on. Well, at 5 volts, I guess it's not going to be that big of a deal. But now we've looked at this before. I got to keep saying that. I would like to figure out where this thing might possibly be getting its pulse train from. And I don't. This is all hex inversion here. Well, hex inversion, and we found a 3-input NAND, which is kind of strange. So, what are we doing over here? Are these just transistors? Might be 5-volt regulators. Let's just check. The full release of the card was green before they did the finished product. Yeah, this is going to seem like something from the 70s, even if it was from the 80s. Just because at that scale, that's all you're going to be able to do. What is that, N or an H? That's an N. NSPN 5134. And a TO, is it TO92? NSPN 5134 data chart. And replacement. Oh no. It's an NPN. Oh my God. So many I gotta get Firefox on this machine. This is getting ridiculous. Oh no, every time I click it, it's downloading another one. You bastards, what have you done to me? I gotta get Firefox on this machine. It's like, oh, how dare you run an ad blocker? You're stealing from the people running those ads. They can't afford it. Like, bitch, I can't look at your website without an ad blocker. Without being absolutely fucking dogpiled by ads. So this is a emitter-based collect. This is just it's just an NPN general purpose that works at 10 volts. Yeah, this is not a proof of concept, this one, but what do we think we're doing over here? Basic logic stuff. There's a couple big caps over there. I don't feel like getting too deep into this, but we are looking for a place that we can tap into and give some kind of a pulse, which may very well be, maybe somewhere around here. Now, I don't think I can run this thing at 5 volts. I don't think that the neon tubes are going to run at 5 volts. So let's look up some of these guys over here. Some of these little bastards and figure out what they are. That'll give us an idea of what the larger voltages are. And we can look at what's right behind it. And maybe we'll see a little bit more justification in the massive, or sorry, in the logic inversion stuff behind there. Why is there orange splattered on everything? 7414 AN, DM 7414 AN. DM 7414. Let's just do that. Datasheet. Why is it all? It's all hex inversion. Everybody's hex inverting with the Schmidt trigger. Why? What? Huh? Why would you hex invert right before a neon lamp? That can't be the right part. DM 7414 1A. 1A. N. You mentioned that the ceramic was sunken in. It makes me wonder if the old chip got super hot and melted and that was a replacement. Yeah, I'm not sure about that. I don't know. That's what we're going to look up next because it looks perhaps not melted in, but that connector is certainly showing something. Yeah, they could have etched this themselves. 7414N, which is an inverting thing. I don't think that's correct, though. 7414 CA4. 7414 1A. 7414 1N. Datasheet, Texas Instrument. Reach compliant. Interface IC. Display driver, TTL PDIP 16. That's not the right thing. What did I get wrong? 7441. Oops. 7441. So 7441AN. Okay, 7441AN datasheet. There we go. Chrome should probably remember that I had looked for these previously. BCD decimal decoder driver. Aha! The plot, it thickens. Oh my god, the datasheet looks like somebody wiped their ass with it. Jeez. 5441 and 7441 is a BCD decimal decoder designed to drive gas-filled Nixie tubes. Dun, dun, dun! It's an ASIC. We have an ASIC. So we have a BCD decimal encoder designed for Nixie tubes. BCD is binary coded decimal. It's just a way of having your numbers in parallel, and that represents your binary number. It's not serial. It's multiple different lines that represent your number. So we're counting from 0 to 10. So we have our A, B, C, and D inputs. Binary number 0, binary number 1, 2, 3. So that's just basically just counting a 1, 0, 1, 1. Over range, what's that? Oh, I see, 0 to 9, and that's over. Why is 0 to 5 on this one? Oh, I see. 5441 and 7441. 74141. 54141. This is very confusing. Do we have multiple of these confusing ones? We have just the BCD for Nixies, BCD for Nixies. We'll look up that one in a minute. I have a feeling this is an equivalent. And then this is the 7441 and the 7441. So each of these has their own counter driving it. And then this one is driven with transistors, because it does the positive and negative. And I guess it could also do X and Y, although I don't know where that would be driven. That reminds me of using the 3.14 megahertz super hex receiver with my ESP32. Few ways to read the data, hex, raw, and etc. Yeah. There's all kinds of, like, the number counting systems of yesteryear are very interesting. But this is binary coded decimal. And what you'll have is you basically, on the 4 inputs, you would give it a number, and then if it gets to overflow, then it will sometimes have an overflow pin that would go into your next thing. Actually, that's more common on the counters. I think this one just doesn't display. All this does is display. I believe that these would be the counters, and so you would be giving them pulses, and as they get pulses, they'll count up on their output pins, and when it's full, when you've got a full, like, 9, hexadecimal, or binary 9, then it will pulse an output pin to say it overflowed on the next one. So you'd pass that off to the next counter. I tried to make something to launch our model rockets that did that type of counting, and I never got it to work. And it was a whole thing. It would have been awesome. Do a little countdown and then launch the rocket. But nope, didn't work. And I used the 555. So early on in my life, I got soured to the prospect of what the 555 is capable of. So anyway, this thing just counts and outputs on its outputs. And so you've got your outputs and your outputs, and then you got your inputs and your inputs and your outputs and your outputs. So the number 0 goes to pin 16. And so if we look here, we have pin 16. Now again, these were born from vacuum tubes, right? All these chips were born from vacuum tube technology. And for a brief amount of time, we had ceramic chips like this, but then we went to the epoxy coated chip. And so you've got a pin here representing the gap in a tube, because a tube's pins go radially around the tube, and there's a gap. So where there's the gap, you have your pin 1. That's the same true of tubes. And you count up from pin 1, going, in this case, well, the flipping of the thing is anti-clockwise, but go all the way up to here, and then your next pin is over here. Because again, the tubes were radial, and then we got squares, and we kept with the sort of numbering scheme. So we count 1, 2, 3, 4. Pin 0 doesn't exist, by the way. 1, 2, 3, 4, 5, 6, 7, 8. So we know that this is pin 16. Pin 16 represents 0. So where on the vacuum tube is 0 gonna be? This comes over here and into this pin right here. So that's 0. Now, obviously, I just talked about circles. These were done in a grid. That makes them kind of unique. I don't know how the numbering would be, but I imagine the data sheet was a complete shit show. And these aren't in sockets, so when these burn out, that's it. You can probably desolder one. I definitely can use hot air these days to do it. I know, ceramic chips are pretty awesome. They make it seem like much different technology. You feel like you're in Soviet nuclear era technology when you look at ceramic chips. And some of the Nixie tube chips that I have that do basically the same thing as this one are in ceramic packages. Good luck getting an inexpensive Nixie tube in this format, maybe. They've been fairly ubiquitous recently. It's not difficult to source them. And I've got, of course, my whole bin full of Nixie tubes as well. 9315/7441. So I wonder if 9315 is a different type of this chip. Belden Incorporated, audio control and instrument. No, that's not what that is. Okay, so that might just be the serial number then for tracking. But yeah, so the 7441, we're basically getting a BCD number into it. And the BCD number, I'm going to assume, is coming from a counter. What's up, Fair Willies? We'll probably have a counter and then something to zero it. Although 0 is already relegated to a button. If we trace that, I wonder if this goes all the way to the back panel. I think it goes kind of over here. How does this button work? This one's a normally closed and a normally open. Doesn't look like it just dumps logic like you would think. There's a resistor divider, and it goes over here. I would think that at some point we would have a stack of counters, as these are. So let's look up these part numbers here. I don't know what this is doing. Chilling working on my RC tow truck. That's pretty cool. The Burn the Subs has these little lights that are actually meant for RC stuff like tow trucks. They're these guys right here. These are actually little lights that do sort of that circular light pattern where it's got like the thing spinning in it. I can't show you right now because Burn the Subs doesn't work. I'm gonna work on Burn the Subs, but those things are awesome to add to that. 1/12 scale. Oh my god, that's huge. That's enormous. Yeah, this is my recent RC thing. I showed this yesterday, so it's just within reach, but the Lancia 074 3D printed body from a low poly model on Thingiverse that uses these little magnet connectors. Now, at some point, we'll have to go back into the 3D model so that I can print the lights and stuff in clear, and then we'll have to make them snap together. That's going to be a whole thing that's going to be very hard for me to figure out in the CAD modeling, but it's an Atom SC2, and it's just getting to be the right weather for me to tootle around with this thing outside, which means it's going to break in a fairly meaningful way. I'm going to take it around one turn, and it'll be like it's on glass, and it'll hit a curb and blow up into a million pieces. But that's okay, because I can 3D print the body again. I just got a 3D printer that takes liquid. I'm going to tell you right now, as per my experience using the Goop 3D printer, is always, 100% of the time, wear your safety equipment. Because the Goop printer, if you get your process down, and again, practice carrying things from place to place, once you get that process down, you want to stick to it as much as possible because the Goop 3D printer is very clean and very good at its job until it's not. And then everything goes wrong and you end up getting the goop everywhere and it's under your nails and it's just terrible. But in terms of like functional printing from the Goop 3D print, I don't get as much of that. You get accuracy out of it. So I was able to even do the little air vents on the sides of the Lancia, and I was able to get every single little detail, unlike the filament printer. The filament printer makes stuff that's strong. What megahertz receiver? 2.4, and it's a FlySky receiver. And it's from DOS Micro. That's it right there. That's a 12 channel, 10, 8? I think it's like 12 channels, I think. It might be 10. And then I've got a gyroscope on there that's also from DOS Micro, and then a motor controller that's also from DOS Micro. Although this is a little big. I wish that was a little smaller. But it is rip-roaring stupid fast. I built this as a thing to kind of race around during the pandemic, but now there's too much dog hair everywhere because we got a corgi. We got a corgi, and she's the love of my life, but she sure does have a lot of hair, and it gets everywhere. And so if I race this around in here, it is basically going to hoover up all of that hair and get stuck. But I love that thing. It's really fun. I like that we were able to give it a nice, cool body on it and everything, because I certainly can't fucking afford used cars these days. That's unfortunate. All right, so let's look at these chips here. The Stage 2. Stage 2, 7419. I'm glad these are in the 74192. Some people have these chips memorized. 74192. Data chart. 74192 of SN. It is, of course, as we guessed, synchronous 4-bit up-down counter. So 4 bits. So we've got 4 bits that are running into the next stage, and the next stage is a 4-bit BCD to decimal. How do they come up with this kind of thing? So yeah, so this is just counting those 4 ones and zeros all the way up, and when it overflows, let's see, where is that? All 4 counters are fully programmable. What do you fully programmable? Wait, this is 7400 series logic. What are you talking about? Each output may be present to either level by entering the desired data and at the data inputs while the load input is low. The output will change to agree with the data inputs independently of the count pulses. This feature allows the counters to be used as modulo n dividers by simply modifying the count length with present preset inputs. This is a crazy thing about this level of technology, is that when you break it down, it is just like clever, right? Everything is just like kind of clever. I make something that counts, and then when it overflows, I'll put this pin. And then somebody's like, wait a minute, I could divide with this thing if I treat this in a particular way. It's really cool. It's very wizardly kind of stuff going on. I got 2 dogs, both Chihuahuas. Ah, that's cool. Yeah, we bought a corgi 3 years ago in a month. Can you believe Will's going to be 3? But she's a really good girl. She's a good puppy dog. So synchronous operations provided by having all the flip-flops clock simultaneously. Flip-flops are something that I don't really have all that deep of an understanding of. Time is going too fast. I know, tell it to stop. A flip-flop is actually a way to have memory in some of these older circuits. You set an input and then you flip it and flop it back and forth. It's kind of a weird switchy sort of thing. And when you get it in logic circuits, it confuses oh bother, basically is what it does. There's a down and an up on these. Ah, interesting. So the pulse train can go to the down circuit or the up circuit. What's up with you, dog? Up 5, pin 5. We're not too concerned with the output. We're more concerned with where this data is coming from. So pins, 1, 2, 3. Oh, wait, no. Where's our... Oh, there's an extra dot right here. 1, 2, 3, 4, and 5. 4 and 5 are also given jumpers, or given test pads. Interesting. Very neat. So all those 4s and 5s, this is what kills me about through-hole, is that I now have to count it from here. 1, 2, 3, 4, and 5. Oh no, that's 4 and 5. What did I, no, it's coming from up here, so, oh, those go the other direction. Yeah, so that's actually, they're just using these as vias, but they're actually larger than the typical vias, so these are also test points. Interesting. I wanted to automate our ceiling fan for my parents with Alexa, but the remote uses something like 340 megahertz or something, and my super hex receiver can read it, but I can't find a transmitter that can speak to it. Aren't there like bridge devices that you can get? I don't know if there's one for 340 megahertz, but I think there are bridges that you can do. When I got set up my 3D printer, if I run into any problems, it's okay to ask you on here, friend. I mean, you can ask me, but I have a whole Discord, and the Discord's full of people that know everything about 3D printing. They know quite a bit. So you can ask there too, because I'm not always available. Yeah, or get a spare remote and do an ESP takeover. Now you're thinking like me. So on the inputs are going to be, so down and up there, and then BO and CO, 12 and 13. So 4, 5, 6, 7, 8, 9, 10, 11. Yep, 12 and 13. So BO and CO are the overrun and underrun, and then these are the up and down counters. So all of those are run just right into each other. The chips are designed to do that. They just run all the way through all of the chips on these two lines. And so it counts up and down and up and down. And then BO and CO are going to pins over here. We can see what that means. So which one is that? I keep my finger on it to make sure I'm hitting the right one. This one right here. So this one is a, oh geez, DM946 or MC846. Which one would it be? Well, DM is 74192, so we'll go DM946N. DM946M. DM946. We'll just DM946 data sheet. We can leave that last letter off. The end of the part number is usually what package it's in. DM9000. We're over 9,000. Well, no, 900. DM946N. Why is it so zoomed in? Not quite. DM946. Plastic dip 14. NAND gate. Not an AND gate. It's a knotted. When you knot something, you invert it. So it's an inverted AND gate. NAND gates are very popular. You hear that come up a lot. Not AND. Oops. Not AND gate. Shut up, AI. Nobody asked you. Not AND gate just means that if you're only if you get a positive input on on the two logic inputs will you get a 0. You'll stay active until you get the positive input on 2. And so NAND gates are apparently really super duper popular for creating large computing structures. And so people ask, how many NAND gates do you got in there? And you're supposed to tell them 2 flops of a blue. I don't know. Anyway, people used to talk in this weird language, NAND, not and. Okay, so I have no idea what this chip is. I don't know if it's not and. Let's try MC846P. The serial number on the chip is indistinguishable from the part number, and that's like a big flaw in the labeling of chips. But I guess the electrical engineer types like to be cryptic and hard to decipher, so we just kind of live with that. The date code serial number is an indistinguishable alphanumeric number from the actual part number. And unless you sat on the toilet with the parts catalog shoved up your butt, you will not know what the individual common numbers are for these devices. It's likely there's a 7400 series chip that is exactly what this is. It's just the company decided to get them from Motorola, so we have to deal with an MC part number instead. Dual 4-stage binary ripple counter sounds right. And it's a 74HC393. Its equivalent MC is slightly different. MC846 from Freescale just says integrated circuits, which is not an incredibly descriptive part number. I'm going to see what that is. Let's see what that is. Okay, this is the generic. Yeah, this is everybody. So MC846. Well, that's 855. Electrical engineers creating their own job security through obfuscation. Yeah. Oh, I see. 0 to 75 degrees, negative 55 to 125 degrees, depending. What the hell are you people doing that you're in negative 55 degrees Celsius? So, where's my 8.4? Oh, it's up here. Oh, it's the same. It's the 2-input NAND gate. A quad 2-input NAND gate. This is one of the most common chips that you'll find. So 74, I don't know about 846. That is definitely a part number that you would memorize. You would just know that. So what are we doing? We're going into two of the inputs with the overflow from the previous count. Although this is way down near the zeroing apparatus. This is way down here. There's multiple views for a reason, so I can point to stuff when I need to. So this is the chip we're looking at, and it is at the, what I would assume is the end of the pulse. That's actually the beginning of the pulse train, because pin 1 is over here, so 5 and 6 are on this side. So the two pins are branching out down to this guy, and that would be our up and our down tick. So this is our initial up and down tick on the lowest digit of the number. And we're coming over here and we're coming over here. So these are this pin and this pin. And the other part of their logic seems to be coming from over here. So it's this one and like this one. What does the input to this thing look like? It's probably standardized. So quad 2 inputs. There's a bottle in front of this keyboard. I gotta move it. Quad 2 input NAND gate. Assuming a typical pinout, which most of this stuff is followed, especially if we are... Essentially, what would happen is they would design this thing using 7400 series logic, and then they would find something cheaper. So they went with a deal with Motorola. What does the board we're analyzing do? This is a digital readout. It's a DRO. It basically, when you have, and we don't really know if it's digital or not yet. That's kind of what I'm trying to get to the bottom of here. What this whole part is digital logic. It's 5-volt logic, and it uses very rudimentary, kind of just easy counting things. The whole functionality of this thing, except for maybe switching of 60 volts, one microcontroller could do this job. But anyway, not even a powerful one too. What's happening is we have some type of an encoder, and that encoder is communicating via two sine waves that are a little bit out of phase with one another, or it's doing pulses. I don't know if that pulse scheme came sooner or later. I think it's probably doing sine waves. I think we might have, although I haven't seen anything that's like analog yet. So anyway, the encoder is communicating with basically an encoder port, which has power, ground, a Z crossing for when it goes 360 degrees, and then the two sine waves. And depending on the position of the two sine waves, that'll give you a position in 360 degrees or linear. And so you put that linear slide on something like a milling machine, and you can advance this thing precisely and know exactly where it is, because it'll show you down to however many digits what the position is. But for us, I just want something that's going to display cool numbers and give you guys perhaps the ability to count up and down. And the simplicity of such a circuit should be low. It should be very simple. Or is it high simplicity? It's high simplicity. It should be a fairly simple circuit. It's just taking us a little bit to kind of get to the functionality of this thing. I mean, we looked over here, we found hex inverters, so it's possible that there's some kind of a direct input from over here. This is a panel on the thing that's designed to be removed, and I guess to calibrate it maybe. This goes to the power supply, which is fairly scary, and there's a lot of other stuff going on in the power supply. But the encoder port comes in over here too. We started over here, and we looked at these chips, and these chips are mostly, they're 7400 series logic chips, but they got them from Motorola, so the part numbers are a little bit different. We found a whole table of parts though. Yeah, the Nixie tubes and 7400 series logic is like all very cool stuff to mess with. It's the coolest, in fact. So these are Nixie tube drivers. Nixie tube drivers make your job easy. A Nixie tube is essentially 10 plates, 0 through 9, of metal that you have to engage with 60 volts on, right? You need to give them about 60 volts and then the neon glows. Well, okay, that's great, but I'm just an electrical engineer and my body doesn't like to absorb 60 volts very much. So having just a binary number come into this thing instead of having to design transistors in order to drive your tubes, way easier. So we use these things. They're great. I love them. You can still get them on eBay. And then over here, we just have binary counters. So when you get a pulse on one pin, it'll count up by 1. And then there's something else to kind of trigger the one output. And that'll make 4 of its outputs a binary number that go to the binary 4-channel inputs over here. Now 9 to 0 is 0 to 9 rather, is you can represent that on binary, but it's not the maximum number that the binary can represent, especially when you got 4 binary numbers, right? You can represent a lot more, many, many more numbers. If you overdo the count, if you send it too many pulses, it then has another pin that will output positively, and that pin is simply connected to the counter that's next to it. So if you count this one down, it'll count this one down by 1 when it overflows. And so you can keep counting this one down over and over again with those 2 inputs until this one counts all the way down, and it'll pulse this one. And this one counts all the way down, pulses the next one over, et cetera, et cetera, et cetera. What the hell is going on back here? I don't know. We'll get to the bottom of this soon. We traced the pulses from chip to chip to chip, daisy chained through until we got to this chip right here. What the heck is this one doing? I am of a mind that this one is designed to flip this one. Actually, no, that would be over here. It would go positive to negative. What are this one then? That one has like nothing connected to it. Unless it's all on the top layer of the board. I guess it is. Oh, so this one, only 2 of the tubes are connected, likely because this one goes from 0 to 5. The reason behind that is when you've got a decimal place all the way up here, the distances that you're measuring back here are infinitesimal. And those infinitesimal distances represent a statistical amount of movement. So it's better to represent it as either 0 or 5 because it could be anywhere around there because we're getting to the limitations of the machine, right? So it's not so much that, you know, we can't display the number. It's more like we don't know. There's the electrical noise in the line of you like farting is enough to skew that number back around. So you basically represent it with 0 and 5. So those are these 2 transistors right here. These would be 60 or whatever voltage this thing is running capable, and they would be intermittently triggered based on, I guess, logic. Instead of putting a whole counter on it, you just have your logic gate doing the counting, and then when it goes from 0 to 5, and it'll send a pulse to the next one. So we're getting to the bottom of what's creating, of where the pulses are coming from. We're getting to the bottom of that. Phew, man. This is a lot. For something so simple, it's a lot of explanation. But it's worth it. This stuff is fascinating. I mean, it's really cool that they, like, you can get to the bottom of the design of something like this and say, oh, they wanted this functionality, so they did this, that, and the other thing. I don't know how efficient they were with all their logic gates, but damn, would I just put a microcontroller on this fucking thing. I guess when this final one counts over here, well, those are getting sent to the missing digit. Dun, dun, dun. And then is there some kind of like a jumper? Are we yumping? We got to be doing something else to the count at that point because we need to flip this to positive or negative. Possibly using... Not that line. Where's that line going? Whoa! This would be like a positive-negative changer. But it's going to that resistor. I don't know what else. There's probably... If I do this, I can kind of see below. Huh. And that... What is that one? That one is from... Whatever the hell that is. What the heck? What is that doing? It's just shorting all these out. Oh my god. It's just eliminated all of them. Maybe that's part of zeroing? I don't know what are these guys doing? MC1810P. We'll look that up in a minute. First, I just wanted to see what's doing the plus-minus changeover. I guess this sits all the way on the outside of the numbers, and when it goes for overflow or underflow, I'm guessing that's what triggers the thing. But like the missing chip, where's the missing chip? I'm totally lost. I don't know where we are anymore. That's way down here. This is the digit that never was. And so this would be the final pulse train would be coming out of either, where are we? These or these. And that's just simply not going anywhere. That goes to the top of the board and goes over like that. What are these guys doing? Oh, those are the binary number. Oh, is that what these are then? Seems to be. These are just like, you could put like you could put like an LED on each of these and watch it count in binary. Neato. I don't know where 5 volts is though. I could solder LEDs in this thing and watch it count. So this is the final, this is where the buck stops. I thought there would be something where if you send it a pulse in one direction or send it a pulse in the other direction, it would change the plus and minus, but it doesn't look like it's doing that. It looks like it gets it from something else entirely. And I don't know what these guys are doing. So 2 transistors, 6 feet apart. Keep making that joke. I don't think anybody knows what I'm talking about. I think they're using this as kind of like a flipper flopper. And there's a diode, and that's a power source. Possibly that's the high voltage. That is triggering. Why is that on the same? Oh, I see. That goes over there. Yeah. So maybe this is the trigger, but that doesn't go anywhere. It goes all the way. Let's check the other side for these two. Freaking through-hole crap. Hate it. Hate this through-hole crap. There's two. There's 2 that go all the way back to the connector. Man, that is a long journey. Okay, so this one and this one, or this one and this one, go all the way back. This and this. Go all the way back. But where else do they go? What's this one doing? You're going down here. Ah. Oh my God, this thing takes a weird path. It does. It's like a little drawing of a wave. Donk. Did you block the world ground? What? You can't say ground plane? I don't think I did. Where's my poker? Poker? It's where my finger is. We should see it poking up through something. Huh. I don't know. I don't think I blocked it. I don't know why I would. Okay, it's somewhere between these devices. Where's my pointer? I don't see it. It should be right here. Oh, is it going up behind the... I lost it. I lost it. We found that point, and then I traced it all the way through, and then... It went on this huge journey to go all the way down to the lowest digit. I think maybe that was the triggering mechanism for plus and minus, but there's just... It's some crazy stuff going on. Yeah, it's this trace right here. Oh, no, it was... Which one? This one. Top one. It goes... Top one all the way down here, and it goes to this hole. And is that in the middle of a device? I think it is. Yeah, because this is the one next to it. That'll probably be able to see. Yeah, okay, so it is. It's this trace right here. And does it go anywhere else, though? Oh, it goes back over to... What the... That's like intentionally done to confuse. So it goes all the way up. Okay, so we're tracing this thing that flips the plus and the minus. It goes up to here, and then we go to... Would you just blocking my view? Everything's blocking my view. Yoop. Bonk. Where's that? Getting closer. We're getting closer. This one right here. Was it this one or this one? Let's say this one. Ugh. This would probably be easier if I used the multimeter just to ohm it out and just made wild guesses about which ones were where. Where's my pointer? Where's my pointer? It's all the way over here. Ah! I got you. I found you. Where are you running? Donk. Oh boy, this is going to be a hell of a thing, isn't it? I'm probably going to have to use ohms in order to figure it out. Okay, so the thought is somewhere down here we are getting our zeros and our fives. They'll probably go from 0 to 5. Let me look at the thumbnail again. Yeah, 0 to 5. See how that last digit is 5? So that's going to go 0505. That's what that transistor is doing. So that means in this area, we are dealing with the pulses that we've created. And we start that counter by going 0 to 5. Oh, that's labeled ground, G and D. Hold on, let me double check that. I don't know if the restrictions apply to me, but yeah, it's fine for me to say it. Somebody else say ground plane. Nobody's listening. Okay, so should you use a marker as a save point to remember where you stopped following a specific trace? That's an idea. That's a way to do it. In this sense, I don't really want to put marks all over it. Thank you. So it was just a weird thing. I just have to make sure that some terminology isn't inappropriately banned. See, on this channel, I don't ban words necessarily. I think I was close to banning a word. But what I did instead is I petulantly made it increase the size of the animation related to it on screen. I don't want to run away from things that fill me with anger. Instead, I want to be petulant about it. Copy the blocked comment and see if it does it again. Yeah. Maybe there was something else that you were saying. So DM946 is, close as I can tell, is a 2-input NAND. Quad 2-input NAND. Which means there's 4 of these things inside of the shell. This is the 7400 series. I have a feeling we are 7400 series. I didn't do shit. It would be Automod that did it. There's our VCC. This is also labeled VCC right there. That's pretty neat. It worked this time. It was indeed a weird bug. Look at these old styles of traces. No sign of a ground plane to be seen anywhere. Yeah, these are hand-drawn traces, possibly using a template, but when they do stuff like this, it's so weird. Like the weird meandering, like look at that. It's like no software was involved in this. So 7400 series, you've got 5 volts and then ground. And then in this case, this thing is wonderfully upside down. Our NAND outputs and inputs, let's see. Well, 946 and 936. 946 and 936. So we were looking at, or what, 836? 836 and 846. 2-input NAND gate. Hex inverter. Racetrack designers. Hey, these would be fun. These would be fun courses. This would be like driving my summer car. My summer car. Why are you emphasizing that all weird? My summer car. Okay, so why do you think it was ground plane and not no sign, which has too many letters from a certain word in it that types things gets auto banned? What? Yeah, that's what I think about that. What the? Mango Scab! Hey, thank you for subbing. For 21 months. Oh, you're talking about the locked comment. Oh. No sign. I don't think it was anything. I think it's just if you got a message that it wasn't able to send, it might have just been a network thing. But if it actually said that the comment was moderated, there's nothing in there that would invoke moderation. So hex inverter, this is a quad NAND gate. So there's our ground, here's our power. Our inputs are coming in here and here. And those are into a NAND gate. Now, where are the gates? Hold on, let me pull up that image. So that one is ground, and then our inputs, yeah, those are both quad, or both inputs to the dual NAND gates. So 1, 2, and that's an output, 3, 4, and then that's an output. So our outputs are here and here. So we'll want to trace those outputs. I want to be careful around the glass tubes that I don't accidentally pop off the little top, the little filler top for it. So this is also getting a logic input from its buddy next to it. And then, and then the outputs probably go into the inputs over here. Duh. So what's coming in on these other pins? So this would be input, input, output. Input, input, output. So wait. Oh God, this thing is so hard to trace. I really dislike this board. I don't like this board. It's very annoying. You flip it and all bets are off. Everything's different now. God. Okay. So get your head together, Bother. You can do this. The 1, 2, 3, 4, 5, the 2 inputs on this side of the counter for up and down come from directly across from it. Yeah, the hand traces are nuts. I think they were using some kind of like a stencil or template, which sometimes they don't. But I mean, I think they're using some kind of a template to get things uniform, because this is fairly neat. All the curves and stuff are very neatly done. It seems like they're like just a little bit over the level of completely like freehand drawn traces. That's kind of a little janky right there. It's cool though. Okay, so 5 and 6 from this guy. there they are, doot doot, going from the output. So this is the 0.001K, I believe that's 0.1 microfarad capacitor. And so this is pin 7 or 14, I forget which one. Pin 14 and 7 are the power and ground pins. So that's these here. And then we are on the pin 14 side. So it's 14, 13, and 12 are the inputs. And they're both coming from over there. And then the output goes to the up or down. So we trace these to our next step, which, great. What is this? What the hell is it? Okay, so we got this one here, and this one, and this one, and this one. So the two that are parallel right here are our up or down. We don't know which one it is. I'm just looking to see. I'm looking at overall surface structures. I'm not looking at individual tiny little pieces of functionality. So this right here is one of our counters. This right here was the one next to it, like above it, also a counter? Might have been. This is going into the reset button logic. And it comes somewhere into this hex inverter. Okay, so where is this structure coming from? Where is it going? Where is this structure coming from? Cotton Eye Joe. But I haven't been Cotton Eye Joe. I've been married a long time ago. Where did you come from? Where did you go? Where did you come from? Cotton Eye Joe. Okay, I'm looking and I'm not seeing. I could pull the chip and look under it, but I would like to figure out where the pulses are coming from that is powering this thing, and then reset, because then we can reset it to 0 automatically, and we can then have it count pulses in either positive or negative directions. And I could do that now by invoking this stuff right here, I guess. These pins right here I could possibly take over. We got a new chip. What's this one? This may be part of the reset logic, or it might be something else entirely, some other feature that we're not aware of. DM945 or MC845. Now we've been looking at the MCs, the Motorola part numbers, using this table of devices somewhere. Buried somewhere in here is a list. There we go. MC 845 and 846. Clocked flip-flop and quad input NAND gate. So we've got a flip-flop. We got a flip-flop doing something. Unfortunately, no. I don't think they went up to 69,420. I'm thinking the flipping and the flopping is what's causing the counting to happen. Because that's another quad NAND. Two quad NAND, flip-flop, another quad NAND. Man, there's a lot of NANDing going on. DM962 or MC862. 86 is... Scroll. 862 dual input NAND gate plus inverter. Jeez. So we've got this big logic structure that's sitting over here. And over here, we have something that's controlling our fives. Something that's controlling our fives through these pins, and I believe some of this resistor stuff going on over here. HV. Oh, that's our high voltage line. Boy, that's close to our regular logic. Where's it going? Oh, this is where it comes from. Where did it go? Where did it come from? Got no idea. What that big got no idea. That pin is high voltage. Okay. All right, we're getting there, Chad. We're getting there. I'm trying to see if there's some kind of a 7400 series structure that is looking at that sine wave and is able to pick apart countings as it goes up and down. Because our counting is coming in somewhere over here. There's some magical pin. Well, there's an up and a down pin over here. What are we asking in chat? Have you seen any tin whiskers and old solder joints? No. Although, I don't know what the orange is over here, and there's like this. That's actually an arrow. Wait a minute. Is that a symbol that they put on the board? It looked kind of like a whisker, but the tin whiskers are totally different. But no, I've seen it in other boards before, but this one is in very good shape. I don't know where my brother got it from. It was probably kept indoors. Is that a tin whisker? So what are these? I think these are responsible for setting us back to 0, but let's take a look at what the MC1810 is. Well, here I've got them, the MCs. So we're looking for 1810. Quad 2 input NOR. What the heck? Is that some way that it's able to set a number? What would that be doing? There's a bunch of NOR gates, so if every digit is connected to a NOR gate, does it just invoke the number the 0 that it wants? Yeah, it's an ink drop from the quill that they designed this board with. I have penned with my quill the new circuit. Let's get that over to manufacturing. So 2 input NOR gate is a knotted OR. The furries will think that's a totally different sentence than what I actually said. When you knot something, you negate it in logic. And so the A and B are basically, so this is the opposite of the NAND. The NOR is the opposite of a NAND. Where if you have nothing on your input, it'll be 1. And if there's anything on your input, it'll invoke a 0. So what does that mean in terms of what's happening here? Quad NOR gate. There's our NORs. Similar to the NAND, only... No, that's pretty similar to the NAND. I think the NAND might have been... Yeah, they're all facing the same direction, whereas these kind of turn around. These are all facing the same direction on this one, though. That calls into question whether or not I can trust. I think this is the standard, but we might have a non-standard. This is the kind of stuff that always messes you up, is when, you buy the chip and it's like this one instead of this one, and so your shit's facing the wrong direction and it blows up. It's very rude. So in this case, we have... And again, a lot of the stuff, like you look where power comes in and you determine whether it's the chip you think it is. Although with 7400 series, it's always it's standardized to a big degree. Logic is a lot of fun. It's because it's all standard. You can kind of play around with structures and you're in your little like walled garden of functionality. So if this pin here, this is supposedly the input to one of the NORs. It goes to that pin, which is another one of the inputs to the NORs. It would be the NOR on this side, so this one and this one, output there. What the heck is it doing, though? Because it goes all the way to, like, here. I think that's part of the reset functionality. This engineer loved negations. I guess so. That looks bad. What I'm thinking is that the logic devices back here are doing something to reset both of these guys. So it'll set this like back to 0, and then this one it'll like reset the count. Let's see, with the 74192, what pin resets the count, if there is one? And there has to be one, right? You got to start somewhere. So down, up, data input, BOCO. Oh, part of it might be rolling the count out. Maybe that's what it is. There might be like a I don't know, like a vibrator or something that'll set all of the numbers to the output. Because there's clear and load. So 11 and 14. So if we look at the clear input, pin 14, how many is this? Is this 16? 3, 4, 5, 8. So 16, 15, 14, this pin right here. Of course, we can't because it probably goes down and over. So if I use the multimeter, what are you talking about? Invert? Yeah, it's not, yeah, we don't typically say negate, we say invert. 16, 15, 14 here. And I'm going to guess, let's get that logic analyzer up here. I'm going to guess that it goes here. It does not. It does not go there. This one, I don't like how easy it is to scratch these traces. They've got pretty weak solder on top of them. You just poke them from the side. So that doesn't appear to go anywhere. Or at least not in the direction that I want it to. I don't like that scratch. What about down here? No, nothing. Huh. What about load, which is pin 11? 16, 15, 14, 13, 12, 11. 11. Nope. None of them? Do they skip this one entirely and actually go up here? Oh yeah, there's plenty of lead on this board. So $16, 15, no, that's 5 and 6. So it's 16, 15, 14. Hops layers and goes that way. What? And what's pin 16 on this thing? 14, 5, 13 and 12 is BO and CO. So this is 13 and 12. Pin 11 is just doing nothing. Pin 11 is load, but it's active low. So I guess it's always loading the letter then, because I didn't see any evidence of a trace on the other side, unless it's one of the ones that goes this way. We tried to ohm that out. So A, B, C, and D are all over the place. Down and up are there. Input data is pin 15. So there's nothing going into input data because they're doing it using the counter, I guess. Huh. The only logic you need is NAND. Okay, I'm just getting a little I'm getting wrapped up in this. One of these areas, like, I'm trying to figure out something is in here in order to clear the count and turn it all back to 0. What's up, ketchup on waffles? Something in here is turning everybody back to 0, and I want to know what. Because there would be a count and then a reset, and we're pretty sure our up and our down counts are here on these two lines because they logic in with something else. I don't know what that something else is, because the outputs here and here go into our up and our down counter. How's this man doing? I'm doing okay. I don't know how much of this we're going to get through. We should have been able to get through more of this, but I've just not been able to suss out the logic of this mechanism. I'm wondering if this stuff here is set up to be like a pulse creator, and it'll create something that will invoke the number as we count through. Yeah, maybe they got a good deal on some NAND chips. I mean, I guess I could try to power this thing up and see what it does, but I don't know where my inputs are coming from. Let's see what the COM port interacts with. Let's see what the COM port interacts with, and that'll give us maybe a better idea of what's going on, because I'm having some trouble here now. I think my ideas are sound. I just need to confirm them, because this chip talks about having this thing where you can load the number into it, and then when you hit the one pin or whatever, it will invoke. I use invoke a lot when I talk about this stuff because basically invoke can blanket over transistors flipping and you know, lines charging up and stuff like that. So I'll just say it invokes, which means it puts the number out on the pins. Let me just read this data sheet for a second here. As ducks go by overhead, I hear honking. What in the world? It's a weird logic symbol. Typical clear load and count sequences. Aha, here we go. So the CLR pin, wait a minute, that's the pin that we should be looking at. Which one is clear? Pin 14. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's the one above our counting pins. So let's just check over here with the multimeter. Smash that pin 14 button. And make a wild guess. Well, that says 215K. I don't think that's down to oxidation. That one's still 200K. All right. 200K. 200K. What the heck? Let's see if it goes anywhere on the other side of the board. So pin 14 is going to be the lower row. Pin 16 right there. 15 goes somewhere. 14. Ah, we've got a big shared bus. Look at us getting on the bus to here, where it's held. I would say that's low. Is that low? Is this a ground? I don't know. I would say that it's held low by this resistor right here. There's something else too going on. What's going on over there? Oh no, that's VCC. We're holding it high. And this is also VCC. This little, is that this? Ground? Okay, it is, that is, what in the heck is this thing? So it's got a capacitor holding it low? Maybe you get a capacitor all the way over here. It's because you want it to pop off. All right, so down we go to where this thing sources from. This would be our reset command right here. Or our zero. Going to that one, which is between those. Which is, oh God. Hey, be careful not to drop this thing. So that's this right here. It's got so much glass on it. Yoink. And then plus and minus get reset? No, that is, okay, so from the switch. So we put something on there and that resets everybody. Reset can also be invoked by whatever the hell this thing is doing. This is a quad, was this the hex inverter or the NAND gate? I forget. Well, pin 3 of the, whichever that one is. That one is the 836. 836. Who are you? 836. 836. Hex inverter. Hex inverter. Pin 3 is just that one, and it goes over to pin 4. So pin 3 to pin 4, we are inverting whatever's coming from the other direction. Pin 3 is an input. So the switch zeros on this line, but it's also informing this thing of something. The clear wire things by the cap, they're clear wires. They're just jumpers. I guess they decided that a clear wire was a better look for the circuit board. Yeah, you can't control F inside of the PDF. Some of them you can, though. And there are more modern PDFs for logic chips sometimes. Like the scans are smarter than they used to be. You can sometimes get through. There's something else going on with this, and I'm trying to figure out what it is. I mean, I guess this gives us a little clue of what's underneath the rest of these, is that we've got our lines coming in, going to various pins, I suppose, and then it keeps going to the Nixie chip where it reaches two of the Nixie chip's inputs. So what are those inputs up here? Those are, let's see, what are we going to? You know what? I think what's going on is there's some other way to display numbers on this board. Two people said the same thing, and I don't know what that means. You can if you OCR them first. You can always OCR them yourself. Came in at the same time. You guys are on the same page, and I don't even have this book. I don't know what you're talking about. Good old days when I ran OCR to my textbooks to be able to control F during my exams. It's some kind of a scan. Okay. Optical character recognition. Man, you guys are smarter than me. Yeah, can you imagine the kids these days being able to control F all their textbooks? I mean, we had PDFs back in the day when I went to school. Barely. Everything was flash animated, though, back then. It would have been really cool to be able to just scan all your books. And now we have e-readers. We have the little tablets that can display stuff. Like, why are we not living in Star Trek where everything is a tablet? Everything's like an e-paper display. I should be able to control F all my books. I guess that's a thing now. I don't know. My brother's kids are apparently still running around with a backpack full of textbooks. I got scoliosis. I had all the muscles on the right side of my body were amazing because I would constantly be doing this deadlift from the floor with all the bags and stuff. So the one side of my body was all muscular. It was terrible. We have the technology for Star Trek. It's just nobody's smart enough for it, I guess. Everyone's just too dumb to have nice things. I have absolutely no idea how plus and minus is working. It's all the way over here. I would assume that when we cross from 0, we're doing something, but I'm a real book guy. I'll never accept the PDF books. I can't work with them. Scoliosis is worth it. My body is deformed and shriveled, but it was sure worth having real books. The professor gave us textbooks, but with images instead of real text to make it harder to control F during exams. Oh my God, what the fuck? You know, control F-ing through information is a very important skill. It is a very highly regarded skill, in fact, at least from where I was working. I'm seeing sort of murmurs of a higher functionality in this board. Something where if you wanted a specific number to be displayed, you could perhaps tickle these inputs over here and it would do that. One thing we haven't done is looked up the product to see what it's capable of doing or if there's any literature about it anywhere. Our PDFs are just scanned textbooks? Yeah, images on the PDF. Yep. Yeah, and then nowadays we've got some pretty powerful OCR capabilities. Now I'm using the acronym. We've got some pretty powerful text scanning capabilities in our stuff. So these old data sheets you can sometimes even highlight text on. This is not one of them though, because nobody really cares about Nixie tubes anymore. This is interesting. So this is not just as simple as a binary counting device. It is, but there's something else grafted onto it that I'm trying to figure out right now. There's a lot of like hex inverters standing in the way. We've got a lot of standard like logic level stuff, but there's some kind of structure of logic that's been sort of tagged on to the back end of this thing. Because I mean, really, like what I'm looking at, what I'm seeing in my head right now is we've got, let me just start a new one of these. MS Paint. So we have our Nixie digit. This is too thin. And that has individual lines. And this would be like 60 volts. Individual lines into the Nixie controller. The Nixie CNT, Nixie counter. So that goes in the Nixie counter, and the Nixie counter uses 4 digits. Or no, not the Nixie counter, it's the Nixie control. This one would be binary counter. And that just gives it 4 numbers, and then it has an overflow. That goes into the same thing. So you would have a train of pulses out here. And anything else is kind of grafted on top of this system. So there's also a reset. That's controlled by a button. And that's high or low or low or high. I don't know what the exact logic is. I'm not going to write it all down. But then there's other stuff grafted onto it, and I'm seeing weird stuff. And so I'm trying to figure out what that other stuff is doing. It's basically at the lowest rung, we have something that's just flip-flopping from 0 to 5, 0, 5, 0, 5, 0, 5. And then the other one's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it kicks the next one over. And to add complexity to that, this goes up and down. So there's over and under capabilities on it. And we know where those traces are. There's the reset logic, which we found out is a lot more simplistic than normal, but then the reset logic is also going to an inverter and off to question mark land. It goes into chat, right? Question mark. Where is this inverted logic signal going? Why does it have another stop? It's possible that this could be stuff that's there for like the more capable system or having the other board installed. But then also, yeah, apparently you guys get the inverted logic, but also there's whatever the hell's going on here where we've got this, which, what did we determine that was? 76, 7612 was, it's like references on references on references. I am having a great time doing this, but 1810, good year. I don't know what happened that year. What happened? Hold on. What happened in 1810? What happened in 1810? The Mexican War of Independence began. Okay, so maybe it wasn't such a great year. Although independence is good. 1810, quad 2 input NOR gate. So that is a quad NOR gate. And the NORs are looking for zeros. Oh yeah, the War of 1810. How did I not? I am not a history buff, chat. I am not good with history. I hated memorizing stuff in school. It's probably why I'm so good on my feet these days, is I refuse to memorize anything, and I had to memorize everything in the short term right before class. I barely made it through my history education. But I'm not doomed to repeat it because I'm not a raging fucking asshole. So, raging fucking assholes ruining, well, my country. This is my country, my damn country. All right, so we've got counter circuits that are up and down. We have resets that are invoked with sort of this big bus, but then it goes out to something else and it goes through like a hex inverter. I just didn't like memorizing stuff. And, you know, the history teachers were really not great. I had a couple really good history teachers though, but I'm just not good with that stuff. I was always a science nerd. These are being held high even though there's nothing in them. Is that high or low? Which one is that? Is that high voltage? Maybe high voltage. It is. No, it's ground. Okay. These are all being held to ground. Yeah, all my teachers expected me to like fucking rule the world by now with science. Science teachers loved me, but I really wasn't that smart. But they are coming from the 1810. The 1810s have 3 lines that they're sharing with each other. I think 3. Hold on, wait. Yeah, there's those 2 there. Those aren't doing anything. I wonder what this logic could be. And why is this one still installed? Oh, because it goes down there. I see. So it goes to 2 of them. 2 of the digits separately. What the heck? Pin 2 and pin 6. 2 and 6. Where's our counter? Oh my God, just give me the logical one. 2 and 6. QB and QC. What? Oh, wait, there's something about that input. What are the Q's doing? Data input B and C. So wait a second. This is a counter, but if you want to, you can program it using those. All 4 counters are fully programmable. That is, each output may be present to either level by entering the desired data at the data inputs. While the load input is low, I'm putting the wrong emphasis on the wrong parts. The output will change to agree with the data inputs independently of the count pulses. Okay, so that's how you invoke a reset on it. I mean, there is reset. That should set it to 0, but in this case, you can give it a number and it'll display the number. We're starting to get to the higher functionality of this thing. There's something going on here where we can give it a number and it'll put that number up. Figure 17, Napoleon Bonaparte decrees that Rome would be the 2nd capital of the French Empire. Interesting. Putting the wrong emphasis on the wrong syllable. Yeah. Okay, so we've got our weirdo gates sitting over here invoking numbers on the inputs. It could potentially be setting them all to 0. But you don't need that. There's a clear button. And we're already using the clear button. What does it say clear does? A clear input has been provided which forces all outputs to the low level when a high level is applied. The clear function is independent of the count and load inputs. The clear, count, and load inputs are buffered to lower the drive requirements. This reduces the number of clock drivers required for long words. Wait a minute. Clear has been provided which forces all outputs to have the low level when a high level is applied. But it's independent of the count and load inputs. What? Then what's the point of clear? These counters were designed to be cascaded without the need for external circuitry. Both borrow and carry inputs are available to cascade both the up and down counting functions. This is what we were talking about earlier. The borrow output produces a pulse equal in width to the count down input when the counter underflows. Similarly, the carry produces an equal in width count up input when an overflow condition exists. The counters can be easily cascaded by feeding the borrow and carry back and forth. Yeah, blah, 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 blah. So borrow and carry is what's cascading us, but we have data input A, B, C, and D. So 15, 1, 10, and 9. We have a clear that clears out our count. And we have up and down. And then the load input, which invokes the number. What the heck? So, but we're using all of them. Pulse, pulse, pulse for up and down. clear loads the preset, but does clear reset the count or not? Clear outputs to 0, load to binary 13. So that loads the A, B, C, and D input. 13, but then it goes 14, 15, 16, 17, 18, and then it what? Well, no, I don't know. Count down to 1, 0, borrow 15, 14, 13. Huh. Okay, so this circuitry is invoking something. It's invoking emotions in me. I can't control, I can't deal with them. But what in the world is going on with this back here? So I see these lines here, this line coming down here, and then this line coming from here as well. And the 1810 is logic gate, and so it has, that pin is ground, so it would be this one and this one, or is it these two influencing this one, which goes down to the next? That seems a little weird. That one is this one? Yeah. There we go. So that's the 4 NORs, I think. Let me double check the part number. Starting to lose my mind here. Yeah, that was 1810, and 1810 was the quad 2-input NOR, which is this little guy right here. So pin 7 is ground, and then 6 and 5 are the 2, and it seems like pin 6 goes into the next one's pin 8. But those are all inputs. Getting a lot of mileage. Yeah, well, you know. This is not an output, this is an input. But this is also an input. I wonder if it, let's ohm it out. Ah, they are connected. So, excuse me, burped in the middle of talking. This input can be set by something, invoked by something. And it would be the bottom of this chip here on the outside. I got to be careful when I put this thing down, because when I put it down like this, I'm putting it down on top of all of the fill necks for the vacuum tubes. So if I am not careful about this, I could end up dragging this on something and popping that little fill thing. Aha, you're going somewhere else that we did not anticipate. Assuming that that's the right side of it. Hold on, do this quickly. So it's the top pin there, and then it goes down to the bottom pin. Does it go to every one on this? So this one goes to this one, that goes to this one, that goes to this one. I wonder if that means that we're setting one line of all of these logic gates that lead to yeah, they are all connected. Okay, so that would be pin, oh God, what the hell pin is that? Is that pin 1? This one's ground. This one's 7. 6, 5, 4, 3. 6, 3, 8, and 11. 8, 9, 10, 11. Okay, 6, 3, 8, and 11. So this, the trace that we're tracing goes to one input of each of these logic gates. The output of the logic gate then goes to something that will reset or something of that nature. Well, actually, the reset's on a button. So what is this doing? Why is it doing that? We're getting to the bottom of this. We're slowly piecing away all of the functionality of this board and figuring out how it do what it do. So it do go here, and it goes to this pin, which is right next to this big row. And so it's at the top of the big row. That's easy to find. Top of the big row. No, top of the big row. This pin. Yoink. And then we're jumping down below before we go, God fucking knows where. Okay, back to the top. Top of this one goes to here. And then is it jumping all the way over to here now? That's exactly what it does. Okay. So wait, that goes there. And there. And then there. And it goes to... God damn it. Pin 15 of this thing. And this is an 846. I think that is the quad. Hold on, let's check. 846. Quad inverter. So it's just this, actually no, this guy right here. Quad inverter. So, what's up, Ketchel? Oh no, you were here before. Oh, you're keeper of maps for a second. Yeah, fun. This is fun. I would call this fun. Fun. That's an input. Pin 13, that's an input. Pin 14 is VCC. Double check. This to here. $1.3K. Ah, what about the pin 14? 400 ohms. Wait a second. Does that just mean it's a power pin? No. No. It can't be. No. It's still got 400 ohms, so I think that's going through a circuit. 459 ohms. Look at him, he's happy. Miserable bother noises. What the fuck is going on with this thing? Yeah, this is, a lot of this is getting into the headspace of the designers of this thing, which is always fun. It's not this one to this one. Oh, that's 0.3 ohms. Oh, because I'm off. Okay, yeah, that's OL. So from here, we get to here. I said, wait a minute. Wait just a minute. Or not. What about here? Oh, it's that one. It's this one. So actually, we're going all the way down here. Actually, we're going down here. Now, we'll get to you later. That was a very weird path that thing took. And now it could be any of these. We don't know. There's no date code on the PCB. It's usually nice form to leave us a date code of some kind. We're thinking early 80s, but we could go back to the 70s of this thing. So we have gone all the way to here. This pin on this thing. This is 862. Double check, even though I've looked it up 50 times. 862 is a dual 2-input NAND gate plus inverter. So we need to look that up. MC862 datasheet. Is this the whole family of... I don't want that one. I want the actual datasheet. Not going to get it. Because this is not a... I mean, maybe it is kind of standard, but... Yeah, we just have to look up. Dual 2-input NAND with inverter. not our, that's not us. That's not us. Let's put datasheet on it. Named. We're getting like new data sheets. I want the old ones. Go with an image search. Maybe that'll give us the more standard. That's a quad NAND, but we're talking about an inverted, a dual NAND with inverted inputs. Was wondering why the PCB has no shielding when all the input is 60 volts. Yeah. Well, it's only all the way over on this side, but it is kind of dangerous to have that much DC voltage sitting around. 60 is my best guess as to what the voltage of the Nixies are. It could be up to 100. But it's probably the lower of the voltages, to be fair. So this is where we run into kind of an issue here, is that I would need to find a standardized, non-standard thing. It might not be standard, having a hex inverter on your dual NAND input. Yeah, this might be something weird. Well, okay, so we can take a step back from this, because I mean, we're learning a little bit more about how this thing is overall functioning, and it would be kind of cute to poke this thing with some 5-volt signals and see what happens. That would be for another day, because I'd have to get all my ducks in a row in order to do that. What I'm curious about is, let's go back to this view. If you can give it a specific number to display, this stuff might be peeling off some kind of a pulse train from the COM port. It's not really a COM port. It's a COM port plug. It's just a D-sub connector, a DB9, I believe. And it's either getting an analog signal or a pulse train. I want to say that it's an analog signal, and this might be responsible for peeling out the pulses from that analog signal as it goes through the waves of an AC sine wave. That appears like, I mean, okay, just looking overall at the board, stuff is happening from here. We come from our port here, going through to this section, which then connects us where? To there, and there splits off in a couple different directions. Some of it is involved in this, apparently. But then we go over to this stuff over here. And so this may be where we were creating all of those signals. That's better than our farm in Morocco, where the electrician put all the solar panels in series, resulting in a 500-volt DC into the inverter. Whoa, that's pretty meaty. I call it the human frying machine. I mean, don't you want higher voltages in those systems? Isn't that better? I don't know. 500 volts, though. That's pretty, that is a meaty amount of voltage. But I guess you save on copper. You don't need as much copper to run it around. Yeah, this thing is crazy. This is cool. This is real like what George Lucas saw when he designed all the greebling stuff for Star Wars. It's like, make it look like this. I love old electronics like this for that reason. Everything is nice and spaced out, and you can just follow the traces around, and they're all kind of a little organic, and it's weird. Why the right angle right there, though? That seems like it put a bunch of limitations on your drawing. So I guess next time we need to figure out what the correlation between the serial port, the counting input, and the beginnings of this are. We know that there is a reset invocation from here. We know that something can tell it to display specific numbers. And we might just be telling it to display 0. Because those go over to these and they stop. Yeah, these don't go anywhere. So these are like test points. And maybe it is that the version of this that could take an external number would actually plug into these. If that's the case, we might be able to take those over in order to put our ESP8266 here. The other part of me wants to leave this completely unperturbed and come in through the COM port with a pulse train that'll set a particular number. But it might be easier to come over here and give it that. We're on an ESP, so we don't have a lot of I/O. This thing must have been fancy at the time. I wonder how much it costs on an industrial budget and how much scaled it costs. But the logic circuits that I think I would be able to find, this one looks melted. The logic circuits that I think I would be able to find are more like workbook problems. They're like little things that the hobbyist can put together. I don't know if I'd be able to really identify like an industrial schematic for something like this. From my understanding of higher voltage, it's more efficient by putting everything in series. If a couple of solar panels are covered, you just get no current at all. But they're all in the same area, so that shouldn't happen, right? It's not so much inflation, it's like scaling the dollar from this day to today. It would still be a very expensive thing because it is, in fact, on industrial budgets. I wonder if 25771 has a date code in it. If it's 1971, that would make some sense. When was 7400 series? Is that 1974? They designed it before the 7400 logic existed? That doesn't make any sense. All right, let's see here. Where are we with this? I'm starting to lose my ability to concentrate. I'll tell you that much. We have an adjustment on the power supply over here with this big meaty resistor there. We have all of our inputs, and this is cleverly done. It's soldered directly to it, and then a card slot to connect it. Those pins are going over to, yeah, we're gonna have to do this another day. I'm gonna have to figure this out. Figure out where the inputs to this go. And we had previously kind of figured something out with it. I was able to tap in and get a number to go on. And wait a second, when I booted the thing up, I got a number on it. There's nothing here that could store a number. That's crazy. Oh yeah, this is earlier today. We opened this up and it is a big capacitor. It's not necessarily a large valued capacitor, but this is the kind of thing that you would see on like a fan motor. Big input smoothing capacitor and a big transformer too. I mean, this thing is creating like what? Probably around 60 volts, and then it makes 5 volt DC in droves. And I don't know if maybe this is a 7805 equivalent strapped onto the back. So you'd probably make the 60 volts and then put it through some kind of a rudimentary 5 volt regulator. So you would have both of those voltages running around. This is the full bridge rectifier, and it gets its own heatsink. Probably not the most efficient power supply in the world. Yeah, and you could pick it up with one hand. God, that thing is annoyingly heavy. We're gonna have to trace out that COM port and figure out where it goes. I have a feeling it's going up to this stuff. Although that stuff coming from here, I'm not sure. So we're gonna do that next time. Next time we get together, and then maybe we can quickly whip up something that will attach the ESP8266 to it. In the meantime, I am going to be fixing stuff for Julian tomorrow real quick. And then I need to breadboard the mixer circuit so that we have something that we can plug into the O-scope, and I can do the O-scope window on screen. It'll look nice. Everybody will ooh and ah, and everybody will just think I'm amazing. Until then, I am going to take the dog for a walk. So I will see you all later. Here's the end card with my thing. I know I'm ending kind of abruptly, but it's about that time, and my brain has just turned into mush. My brain is completely turned into mush. We did a lot of reverse engineering today. We looked at a lot of logic stuff, and we understand this thing just a little bit more. Wait for what? What am I waiting? Why are you making me wait? You have 2 days, 20 hours, 29 minutes, and 58 seconds. Oh, the moon smiling thing is tonight? There's no way I'm getting up before dawn. I thought you had to get up before dawn to see it, so... But yeah, pretty cool. All this is a basic implementation of a TTL logic, a TTL logic binary counting system that adapts to Nixie tube drivers. And these are basically 0 to 9 counters that have an over and underflow that are cascaded. So you would send this thing a billion pulses, it would flip from 0 to 5, 0 to 5, and then when that flips from 0 to 5, every other pulse goes over to this one, and then every 10th goes over to this one, and then every 10th goes over to this one, and blah, 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 blah. And then when you hit reset, something is being pushed or pulled over here that will set these guys to input on the inputs of the, I don't actually know if that's the case. Hold on. So if you hit reset, there's actually a daisy chained pin that resets these to 0. I don't know what's going on with these. I don't know if there's something where I can send it a number independently and then it'll change over that number. That's what we don't know. We don't know this. We don't know this. We don't know this, because these are lots of individual logic gates that are doing stuff. So there's still a lot of questions to be answered, and luckily we can get there. We can get there because this stuff is a little bit simple. It's just my soul left my body at some point while we were doing this, and I'm just a shriveled husk of a brain. Barely functions. No, it's not that bad, but I just need to go take my dog for a walk and get some hydration in me. And I will be back on Tuesday, and I will see you then. Have a good weekend, everybody. There it is.